was not supposed to be like that. Hello, everyone! Sorry for botching the stream start. It's been a while since I've done stream. It's been a long while since I've done a reverse engineering stream. So, welcome back, existing viewers. Welcome everyone new. And yeah, so what do we have today? We have a new project. We have a new project that I'm very excited about. And yeah, so I'm going to be looking at Live2D MOC3 models. So I assume most of you probably saw my tweets about this. If you didn't, well, there's actually a conversation we should have and recap things before we start the stream. So the short version is I'm going to be reverse engineering the Live2D MOC3 model format, which is the model format that almost every 2D VTuber uses for streaming. It is the format that is used to load models into VTube Studio. Yeah, it's kind of the backbone of the 2D VTubing industry. And we're going to be taking a look at it because so far there has been no asterisk here. Real project to figure out how it works, and it is a proprietary file format that has no third-party applications or tools or absolutely anything. So yeah, how does that work? Actually, give me a second. I'm getting a projector here so I can see what I'm doing. There we go. So I can see myself. So yeah, why do this? Okay, so first of all, because reverse engineering is cool. And because it is a mystery, and mysteries are fun, and because learning how things work is always a good thing. But more importantly, I have a little document that is linked in the video description, which I will encourage you to check out. And I'm going to be just roughly going over the points in that document before we get started. So, is this a clean room rewrite? Yes. And actually, I'm going to get myself some water or something because I forgot to do that. So I'm going to give you a minute to open up the doc if you want to take a quick look at how things work. Give me just 1 minute. I'm going to grab a bottle of water or something because I just realized I forgot that and I'm already thirsty. All right, lightning break. All right, so let's get started. This is the end goal, an open source version of Live2D. Eventually, maybe someday, possibly yes, but there's a long road until we get there. So first, let me get a quick drink. And let me say hi to everyone before we get started. So, hello Jupiter, hello Mary, hello Idendeku, hello JPixel, hello Wolfo, hello Stellar Cube, hello Exasker Lily, hello Tyrion, hello Mart 7, hello Max120 Pink, hello Nexudama, hello Professor Handra, hello Case Cami, hello Sophia, hello Fluffin, hello Totally Not Yet, hello Anna's Rosengarten, hello Horeza, hello Pastora, hello Jack, hello Full Course, hello, Source Speed, hello Jay, hello, is it all? Hello Rin, hello Petster, hello, did I say Kiskami? Hello, Totally Not Yet, hello, Luxamelia, hello, Winter Charm, oh, hello, Rem Revo, hello, Dummer Tracks, hello, I think that's, hello Cross, sorry, hello Cross J, hello, Solomon, hello, Kachika, hello, Tsukakase, hello, hello, I cannot read Korean, I'm so sorry, hello, Birdie Jess. Alright, so yes, what's going on here? Why would you reverse engineer the Live2D format? Well, first of all, Documenting file formats is a good thing because it helps ecosystems, it helps increase diversity, it helps people write new apps, new tools, new things, create new stuff for an ecosystem. So as an example, in the 3D VTubing world, basically all file formats are already open, whether they were reverse engineered or already open to begin with. So one good example is FBX. If you get a custom 3D model commissioned, especially a full custom one, not like Vroid, chances are that at some point you will hear the word FBX. That is a model format used quite often to export files from Blender into, say, Unity or something like that. You can use it with Waterdo to transfer files between different applications. And that FBX format was originally proprietary. It was created by a company, and they had an SDK, and it was a more open SDK than the Live2D SDK, but it was still an SDK, a binary SDK that you had to use FBX files. And so there were limitations on how to use that SDK. And so the people at Blender said, hey, we want to use FBX files. We can't use this SDK for technical licensing reasons. So we're going to figure out how FBX files work and make our own software to use them. And so today you can export an FBX in Blender, and that is thanks to reverse engineering. So the 3D VTubing world already relies on reverse engineering. Another example is doc files. So good old Microsoft Word 97 era doc files, not the nice modern docx ones. Those were also reverse engineered. They originally were used only for Word, and other people figured out how they worked. And so now you can open doc files in LibreOffice or Google Docs or whatever. And all that is thanks to reverse engineering. So reverse engineering is a very important thing to increase diversity in ecosystems. It means anyone can work on a file format, not just the people who designed it. So that's one reason. The other reason is that specifically Live2D actually forbids using their SDK in open source applications. They have very strict terms for using their SDK. The licensing is honestly quite strangely restrictive, and they outright ban open source apps from using the Live2D SDK and having like binary releases. So you literally cannot have an open source VTube studio. It's banned. You can't. So we need to fix that. We can't use the Live2D SDK. It's banned with the Live2D SDK, so the only option is not using the SDK. And to do that, we have to reverse engineer the file format. But then, and probably the reason why most new people are here today is that there is a huge discourse that has been going on over the past few days on Twitter about VTubers versus riggers. And the point of contention is, are VTubers able, and should they be able, and should they be given the source files required to edit their models? The way Live2D works is that you have a project file that's called a CMO3 file, not MOC3, CMO3, and that project file is what you edit to edit the rig. However, when you export the model, you export a MOC3 file, and that file is a black box. You cannot edit it, you cannot re-import it. You can only use it to make animations, but you can't change the rig in any way. And so what happens, unfortunately, very often is that riggers do not provide the source CMO3 files to their customers. And then that means the customers have to ask them if they need to have the rig changed. But then if the rigger loses the CMO3 file, or just disappears, or goes to the client, or something happens to them, or life happens, people aren't always available. That means that the customer has no way to edit their model. And unfortunately, that means that quite a few people have had to have their models re-rigged from scratch because the original rig was lost. And that is a tragedy. That is really sad. However, there are reasonable reasons for a rigger to be reluctant to share the CMO3 file, because the CMO3 file is essentially the high-level editable workflow file for their entire rig. And so it essentially discloses their, the techniques they use for rigging. Now, we can have a big argument about whether those should be free to share, and everyone should be able to see exactly what was done. That is a conversation, that is a completely different thing. But the main problem that I want to focus on today is that this is an either-or situation. Riggers either give the full CMO3 file that can be fully edited, investigated, and inspected, and absolutely everything, or they give the MOC3 file and then nothing. There is no in between. And that is weird. No other art form anywhere works like this. If you commission artwork, you get a PNG. You can open the PNG in an image editor, you can filter it, you can draw on top of it, you can modify it, you can change the colors, you can do whatever you want. I'm not talking about whether those things are ethical, whether you should be allowed to do anything with a commissioned artwork. Those are, again, different questions. We're not focusing on those today. We're not focusing on what is technically possible. You can do all of those things. If you commission a song, even if you just get an MP3 file, you can still edit it. You can run it through a vocal extractor or vocal remover. You can make a remix. You can cut it up. You can fade it in. You can fade it out. You can use it as a soundtrack. You can sing on top of it. There's all sorts of things you can do. That doesn't work for Live2D. There's nothing in between. It's really strange. The closest comparison I can come up with to this situation in Live2D models is actually with music. Because when you commission an arrangement from a composer or arranger, they will be working in a digital audio workstation. They will have a project file that has all their tracks, that has all their plugins, that has all their settings, that has all their presets. Very often that arranger will have a template project file that they have with their signature sound. People very often use the same presets, the same plugins, the same sound sources, and the same settings, and people create their own unique sounds that they use in their songs that give them their, their feeling, their style, right? And while it is very, very, okay to listen to a song and try to copy something, that is how you learn. That is how how art spreads. I've done that all the time. When I was learning music, I would listen to songs and try to recreate them from scratch. However, that is different to literally getting the original project file with every single setting down to the 15th decimal digit on every single thing the original person did. And if they are using a template, they might have tracks they don't even use, right? So they have tracks in there that have nothing in them, but they're used for some songs and not others. There are good reasons not to give everyone that project file when someone commissions you to make music. And in fact, it is almost never done. When you commission music, you almost never get the original project file. What you do get very often, besides the final song, is what is called a stem export. A stem export is basically a separate WAV file for every single track, often without effects or with limited effects, and without master effects, or it sometimes can have some master effects. The idea is that then you can take those separate tracks that have each instrument, each part of the song, and remix them. You can take some out, put in your own, you can mix them with different effects, you can change the way the song is mastered, you can do all sorts of things with those files. And so those files are very often used to make variations of a song, to make derivative works of a song. And any competent, any reasonable arranger will give you those stem files. And they might charge a tiny amount of money for, the labor of exporting them and making it nice and everything, but they're not going to charge double for giving you stems. That flexibility is what lets people have things like song remixes and means that customers are not stuck with a certain person. And in fact, even the original project file very often is not that useful because it relies on all sorts of plugins. You can't even share them. You have samples that you're not allowed to share as samples. You can only share them as separate, as like a part of a mix, part of a song, a completed song. So, and often the project file won't even work years down the line when you've, upgraded your computer and the plugins have changed. So the project file isn't even future-proof. However, those stem files are. That's what we need, right? That's what rigging needs, is some kind of way that people can change a rig after the fact and make large-scale changes. Add a part to a rig, add an outfit, fix a little problem that it has, change the colors, rearrange something, add a toggle, add an add-on, add an extra pose, something like that. You don't need the original file to do that in principle, in a perfect world. we just can't do that right now because there is no way, there's no in-between between the full original project file and the final black box that you cannot touch. And that's what we're trying to solve here. We're trying to give people a way of editing MOC3 files. And my computer's going to sleep because I haven't clicked the mouse too much. Oh, it even locked. I need to fix that, otherwise it's gonna keep locking during the stream. 1 second. So I'll give you a second to digest that because that's really the big thing we're trying to work on here. Require password after 5 minutes. Fix my screen settings so we don't get a big lock screen here when in the middle of the stream. All right. So yeah, that's the story. And then finally, there's one more reason to figure out MOC3, and that is that right now the only way to play back Live2D models is using Live2D software or their SDK embedded in some other software. But companies don't live forever. Companies start up and shut down and go bankrupt, and everything happens all the time. And if there is no open documentation for the file format, there is no way to guarantee long-term that those models are not going to be lost. And I think art being lost is another tragedy. And of course, it's no good for customers either. But even if we're talking, 30 years down the line, is it really okay for 30 years later to all these model files to become unusable? I don't think so. So by reverse engineering the file format, we can make sure that there are alternatives that can be maintained. Even today, there actually is not that much software you can use to play back MOC3 models. VTube Studio is one of them, and VTube Studio only runs on Windows and on Intel Macs. I found out just before the stream that the public VTube Studio build for macOS is only built for Intel, so it will stop working on Apple Silicon Macs in the next few years. I assume Denji's gonna fix that at some point. I hope so. But still, that's kind of scary, right? So, yeah, that's something that I think is also very important, is that we have alternatives. We have more than one piece of software or one SDK that everyone has to use to show Live2D models. And yeah, those are my reasons to reverse engineer this. So for those who are new, who are just joining, I kind of know a lot about reverse engineering because I've been doing reverse engineering since I debuted as a reverse engineer VTuber. I used to work on reverse engineering the Apple Silicon GPU. So Apple's new GPU, well, kind of new. They've been doing things like that on iPhones for a while, but the GPU used on the new Apple Silicon Macs, I reverse engineered how the hardware works, how the low-level interface works, and in collaboration with a couple other people, we wrote a full Linux driver for it. And that Linux driver was eventually certified as OpenGL 4.6 and Vulkan 1.4 conformant, which means it was officially meets all the specs. And Apple's driver doesn't. Apple have their own Metal API, but they only support an old version of OpenGL, and did something just drop? I don't know. And they have bugs, and it's not conformant. Apple's driver is not certified on anything. So what that means in practice is that if you run Minecraft using our driver on Linux, it runs better than using Apple's driver on macOS, which is kind of hilarious. So if you think that reverse engineered software is always going to be inferior to the original, you'd be wrong. And yeah, I have a lot of experience with it, so I am not new to this by any stretch. Well, you can pay a lot of things. You can pay way more than Minecraft, but Minecraft is a really good example because it's an OpenGL game, and so especially if you use weird shaders and stuff like that and mods, it actually runs better on Linux. So the next question that is going to pop up, because people are going to ask, is it legal? Are you allowed to do that? Are you allowed to reverse engineer things? Yes, if you know what you're doing. So the first thing that we have to discuss is that copyright protects creative works. when you create something that is creative and that is a very specific thing, like a software application is considered creative, or a VTuber model is considered creative, those are protected by copyright law. And all the copyright things that we're not going to go into apply to that. However, copyright does not protect utilitarian things. For example, if you buy a wrench, you're allowed to see how that wrench works and copy it. Now, there's a different thing called patents, and patents can protect utilitarian designs, but that is a different story. However, copyright does not. So a file format is kind of like that, but it's even more abstract than a physical thing you can patent. A file format is basically just a collection of facts. Like, the file format exists, and when you document it, you are just explaining how something that already exists works. So, for example, you can buy a wrench. You can figure out how it works. You can write even a PhD thesis on how to design wrenches based on designs of real wrenches, and you can publish that. And that is 100% legal and absolutely not infringing on any law in any country. You may or may not be able to manufacture your own wrenches using that information if there are patents, but you can certainly talk about it. So file formats are like that. File formats are just things that exist that you can describe, and those descriptions are not creative. They are facts, and you cannot copyright facts. You can copyright collections of facts, you can copyright an encyclopedia, but you can't copyright the information in that encyclopedia. You can't copyright the reality of the world. And that is how file formats works. And as I mentioned, that is also historically how it has happened. File formats have been reverse engineered time and time again, and sometimes the people who design the file format get mad and get upset, but legally speaking, they don't really have anything they can do about it. So, the next question though, because people will, there are caveats and asterisks here. So, doesn't this violate the Live2D software license? Live2D has a very complicated license, and thankfully, I have nothing to do with that, because I do not have any software. I have never used or downloaded any software that is licensed by Live2D Inc. The only software that I am using and have used that has anything to do with Live2D is VTube Studio. And VTube Studio is a third-party application that happens to use the Live2D SDK, but it has a very standard license agreement. And so whatever license is between Live2D and the developer of VTube Studio has nothing to do with me, because I am not required to agree to that license. I'm only required to agree to the VTube Studio license. So whatever license Live2D has with its customers has nothing to do with me. And the next question is, don't you have to reverse engineer the software, whether, Live2D software or VTube Studio, to understand the MOC3 file format? And the answer is no. So with things like file formats and protocols and hardware, you can reverse engineer those things without reverse engineering, and there's a specific meaning to this, the software that interacts with them. When we talk about reverse engineering software, we talk about disassembling, decompiling the software. That means taking the binary software and turning it into source code of some form that you can then use to analyze how it works. Doing that it touches on the copyright of that software, because you're modifying it to turn it into a different form, to analyze it. So when you download the software, the license agreement can say, hey, you're not allowed to do that. However, you don't need to do that to figure out a file format. There's a style of reverse engineering called black box reverse engineering. And what I described earlier, the decompiling software, is called white box. That means the box is open, you can look into it, you can peek inside and see what's going on. Black box means you leave the box closed. You don't open the box. Instead, you just look at what comes in and out of the box. So when I figured out Apple's GPU, I did not decompile Apple's driver, at least not until a tiny little thing that happened once in one stream way later, but I could go into the legalities of that. But 99% of the time I did not. I was just running applications that do things on the GPU and then looking at what the driver does with the GPU. And in that case, we used a hypervisor. We used there's a whole story here. We had a virtual machine technology we used to analyze how the driver programs the GPU. And so we could compare how we tell an app to draw something on the GPU and how the driver programs the GPU to actually draw it. And by looking at that many, many, many times over, eventually you can figure out how the GPU works without necessarily knowing how the driver works. I don't know what algorithms are inside Apple's driver. I don't know how Apple's driver is designed. I don't know how it achieves what it achieves. And I don't care, because the only thing I care about is achieving the same thing. I can come up with my own solution to achieving what Apple's driver achieves. I just need to know what the inputs and the outputs are. Think of it like a test-driven development. You use the original software to create a series of tests, and then you create software that passes those tests. And you don't have to copy the original software. So with Live2D, the equivalent of this would be looking at MOC3 files, analyzing them, seeing how they compare to the actual model that comes out when you open the file, and then eventually modifying the MOC3 files, creating my own MOC3 files, opening them in VTube Studio, and seeing how they render. We don't have to figure out what VTube Studio is doing to render those files. We only have to know how the input, the file, corresponds to the output, the rendered model. That's all we need to do. Let me take a drink. So the next question is, didn't people try to do this and got sued? Okay, as far as I know, obviously I'm not privy to all legal action in the world, but I've never heard of anyone getting sued by Live2D Inc. or anything like this. However, there have been a few prior attempts at reverse engineering MOC3 that got some legal threats from Live2D, and some things were taken down, and the story is not very clear. There's not a lot of information about exactly what happened and what was discussed behind the scenes. However, what I do know is that as far as I know, every person that has tried to do this so far has actually decompiled the Live2D software or something using the SDK, or at the very least, they have downloaded Live2D's SDK from like GitHub and then used information from that. And even Live2D's SDK has an open source component. They have a bunch of open source code you can look on. I say open source. Source available is the term. They have a bunch of source available code on GitHub that creates a high-level framework around MOC3, and then they have a binary library that actually reads the MOC3 file. That source code, however, is not free and open source software. It is not distributed under a free and open source software license. It is distributed under a restrictive Live2D license. So even though it's on GitHub, even though you can technically open it up and look at it and clone it, by doing that, you're agreeing to the Live2D SDK license. And so then they have a case. Doesn't mean they're going to win a lawsuit against you, but they have a case to say, hey, you broke our license. And essentially, that doesn't mean that if you do that, you can't touch MOC3. But the whole game in reverse engineering is basically cover your ass. And in reverse engineering, we call that doing clean room reverse engineering. What clean room reverse engineering is using techniques that essentially give you a legal defense, a legal guarantee, mostly, that it's something you can go ahead and tell to a judge that basically says, hey, I did this way, and the way I did it guarantees that I did not copy anything copyrightable from this person. And what I described as black box reverse engineering is a form of clean room reverse engineering. It achieves the same result as traditional clean room reverse engineering. Traditional clean room reverse engineering is when one person looks at the binary code and decompiles the software, writes the spec of the file format, and then another person implements that spec separately, so you can guarantee you didn't copy any code. Now, that still could potentially violate the license. However, in many countries, but not all countries, doing that is legal. In many countries, but not all countries, there is a legal right to reverse engineer for interoperability purposes. If you live in one of those countries, you are allowed to decompile Live2D's SDK, figure out the file format, write a bunch of documentation, and then have someone else take the documentation and write an open source tool to use MOC3 files. That is a plan that is legally solid in some countries, but not all countries. And I don't think Japan's one of those countries. And I live in Japan. So I cannot risk doing things that way. However, other people can. But if you do what I described as a black box reverse engineering, which means you're not decompiling the software at all, then, well, the end result is essentially the same. There is no way you could have copied anything from the SDK. And on top of that, you didn't decompile or reverse engineer the SDK itself. So there's no way you could have violated their license. So Live2D could come and try to DMCA, my GitHub repo, but that would be a false DMCA claim. That would not be something that honestly interprets, the legal reality of what is happening. And, I'm assuming that they will not try to sort of frivolously sue me for something that they have no legal standing to sue me for. If that happens, I'll find lawyers. But I have a pretty solid, legal defense against any kind of legal action from them, as long as I am very, very careful about what I do. And that's the same thing we did with Apple, by the way. So, how can you test reverse engineered files? I mentioned that we're going to use Live2D. As for the goals, what do I want to achieve with this? I already mentioned the general reasons why doing this is good. What I personally want to do is, first of all, I want to make an open source alternative to the Live2D SDK. I want to have a library that can read MOC3 models and eventually render them in, say Godot or any other engine you want to use. And the goal there is essentially an open source VTube Studio alternative, because as I mentioned, Live2D's SDK license actually bans open source software from using it. So I want an alternative that I can use to use Live2D models that I commission from riggers, and that I can modify, that I can change, that I can run and compile for Linux, for macOS, for whatever I want. That's my first goal. And, I mentioned the whole story about fixing MOC3 files where the rigger lost the file. But the thing is, being able to display the MOC3 file in the first place, identically to VTube Studio, is kind of the test case, right? Even if your goal is actually to do something else with MOC3 files, to prove that you have an understanding of MOC3 files, you kind of have to be able to render them. So this is, even if you ignore, personal priorities, this is kind of a worthwhile goal in and of itself. So the second goal, and that's what I mentioned recently on Twitter, is I would like to write tooling to adjust and improve MOC3 files. The first example I have is actually more limited than what I mentioned, which would be, for example, an optimization tool. I would like to be able to have a tool that can take a MOC3 file and simplify it and say remove some vertices and reduce the texture size and do some other changes that intelligently, I'm not talking AI, I mean mathematically, removes, it's like lossy compression, right? It's like removes parts that make little difference in the output and reduce the resource usage of your model without really messing it up. I think that is possible. I think that is a thing that can be developed. I think that is something that would be very interesting to a lot of people with more limited computers. And I think, in fact, that it makes perfect sense that you probably want to have different versions of your model, one that is lower quality, one that is higher quality. And I'm not just talking about the texture size. So I think that's an interesting tool, and it's an example of the kind of thing that can exist and help everyone, help the ecosystem, if we can work with MOC3 files. And then finally, not finally, but like getting to the thing that I mentioned on Twitter, I would like to develop a limited editor for MOC3 files. Not a full, at least not yet, not a full rig tool, but rather something that can be used to post-process MOC3 files, something that can be used to split a rig into multiple files, combine multiple rigs into one file, make adjustments to the parameters, make adjustments to the range, the weights of the rigs. So you could use this to make, for example, you could have a new outfit. You could probably not add an outfit in this tool, but rather you could rig an outfit in Live2D Cubism, export just the outfit as a MOC3 file, and then merge it into your existing model, so that then you can have one combined model that has the new outfit and the old outfit and everything else. Now this would basically be a limited destructive editor, right? You can think of it as like taking songs or PNGs and inserting them, loading them again into a audio editor or into a image editor. You can combine them, you can, split them, blend them, but it would not be able to completely edit the original data in the file. Certainly not the settings that were originally in the file when it was made in the original project. And now the final question that people are going to say is like, well, are you going to actually make an alternative editor so you can make and rig Live2D models from scratch entirely in open source tools? That's not my primary goal, but I think that would be a very interesting long-term project. However, that is a huge project. That is not something I can do myself alone. That is something that I'm going to have to find a bunch of people to work with me on, because I am not the best person at writing graphical editors, and I'm also not a rigger. I did rig my original model in some other software, but I'm not an expert in everything. I am good at reverse engineering, and I can write software, and I can do some things, and I have opinions, but I am not, I can't do everything. So if we are going to go in that direction, that is going to be a community project. It's going to need more people. And that is also way down the line, because we need to figure out MOC3 first. So that's a very interesting goal. I would love to work on that over time, but one step at a time. All right. Am I going to get Live2D mad at me for this? I don't know. I mean, I don't hate them. I don't wish any harm. I'm not trying to put them out of business. Even if we do this open source editor thing, I don't think they're gonna, lose all their customers. I'm sure they have, things that they'll do better, and competition is good, right? So I do hope that maybe by working on this, they will be encouraged to develop features like maybe importing MOC3 files back into the editor so you can do limited edits on existing rigs. It's up to them how they react. Another question that is going to come up is, am I going to reverse engineer the CMO3 format? That is the project file, the actual rig, editable rig file that Live2D Cubism editor uses. Now, I personally have no plans to do that. The reason is that to do that, I would have to use Live2D Cubism editor. I would have to use it to test everything, and I don't want to enter into any license agreements with Live2D. So I am personally not going to work on CMO3. However, if someone else wants to work on that and they have their own, their own legal plan for how to make sure that they are not breaking any laws or any contracts, and they want to use my MOC3 reverse engineering information to work or do something, that's up to someone else. But I'm not personally interested in that. Any hypothetical open source editor for rigs that we work on would most likely have its own project file format completely from scratch, and then just export models to MOC3, just like Cubism does. Right. Will this mean that people can just take MOC3 files and turn them into CMO3 files? Whether because of what I do or because of someone else developing this. I don't think so. The MOC3 file is almost certainly not equivalent to an editable CMO3 file. It's not like Cubism takes your rig project and then just like encrypts it or obfuscates it, or just makes it so you can't edit it even though it's not really doing anything. I don't think that's how MOC3 works. I think MOC3 is a lower level file format that has parts of the rig simplified and baked and basically turned into a form that is more efficient to actually load and render. And so by implication, that means that most likely you can't take a MOC3 file and go back to the original project file. You could take a MOC3 file and go back to some project file that you can edit. However, that project file would not look the same and would not have all the same information as the original project file. This is the same as compiling software. You can compile source code to an executable, and there are decompilers that can take the executable and produce source code. But in most cases, you're not going to get the original source code. You're going to get a much rougher version. At the very least, you lose variable names and things like that. But unless it's a high-level language like C# or Python, you're going to get a way different organization of the source code. There's going to be bugs. There's going to be issues. So I think MOC3 and CMO3 is going to be like that. it's almost certainly possible to do a lossless conversion from MOC3 to CMO3 in the sense that if you then export a MOC3 again, it will work the same way as the original MOC3, but you're not going to get the rig. You're not going to get literally the project file the rigger made with all their settings and all the exact rigs done in the same way as the original rig. So why not just use an open source format? Well, there's no open source alternative to Live2D that is credible right now. And even if there were, you're not going to really gain much traction when the entire ecosystem is using Live2D. How are you going to convince people to use this alternative thing that is different and not compatible? I think that even if your goal is just open source VTuber models, there needs to be compatibility with MOC3 because the entire ecosystem is in MOC3. And like to gain traction on the ecosystem, you need to be able to work with the people that are already in it. So to do that, we need to figure out MOC3 first. I support any effort or project to develop an open 2D animation ecosystem. And I'm happy to collaborate on MOC3 compatibility. But I personally think MOC3 compatibility is a very important requirement for this to go anywhere. So then why is this good for the average VTuber? I think we already talked about a little bit about that, about how it works, and why, why rigs get exported and why you're stuck with that. So that was at the beginning. And yeah, so some riggers will say, well, I don't want people to mess with my rigs, right? Like I made a rig and it's my creative output and I don't want people to modify it. And I think that's not right. I think I have a right as an author to not have my files messed with. And you're not wrong, but that is a moral question, right? That is a moral and legal question between you and the customer. So what I'm going to work on does not mean that suddenly anyone can take any model, any rig and do anything they want to it, because they still have to abide by copyright on the rig itself. They still have to abide by whatever contract they have with the rigger and moral rights and all sorts of things. This project is a project of, it's a technical project. It's a project to figure out the files and have tools to let you do things to the files. That doesn't mean that doing those things, doing anything you want, is the right thing to do. Just like taking a PNG and drawing over it is generally not a thing that artists like you to do, and it could be a copyright violation. It's the same with MOC3, right? I am not saying, hey, it's a free-for-all. Now everyone can just go and edit their models and do whatever they want. No, okay. I think there's a whole separate conversation about what you should be doing with your model files, and riggers and customers need to enter into contracts that make it pretty clear what is allowed and what is not allowed. But I think we need the tooling to be able to do these things first before we can worry about what you should be doing. And then finally, I know some riggers. There's some. Let's just say, not very. This is not the majority of riggers, but some riggers do believe that they have, sort of the moral right to be the only person allowed to touch your model. Now they can do that, but please, if this is your goal, if your goal is to ensure that your customer comes to you for every single revision to their model, please make that part of your contract. That has to be something you legally spell out for the customer and that they know. That should not be something that just happens because the MOC3 file format is not something they can modify. That has to be something that you spell out in a contract and tell your customer, hey, you're not allowed to touch this. I have to make all changes, and if I'm gone, you're stuck. If that's what you want to say, you can say that, but you have to say it in legal terms with your customers. On the other hand, even if we have a MOC3 editor, remember, if you're a rigger, you're going to be in the best position to offer modifications and improvements to the original rig because you have the original CMO3 project file. What I'm trying to work on is an alternative. It's a workaround. It's a limited, inferior alternative to making the changes in the original rig file. It is to give people options. It is not to replace the original option of editing the original CMO3 project file. So as long as you have a good relationship with your clients, there's no reason why they won't come back for new outfits and new changes. This is just giving people more options. And it cuts both ways because it means that if you're a rigger and some other rigger disappeared and left, goes to their clients and they're stuck, you can help them get new outfits without having the original CMO3 file. So it works both ways. All right. I think that's everything I wanted to say for the introduction, because there's a lot of things that are very subtle here. I'm gonna make sure there are no misunderstandings. So let me go back and drink a little bit and drink some water and look through the chat, and then we figure out how to get started. Alright. So what's going on with the chat? Sorry, I wasn't paying attention when I was going through this entire spiel, because I want to make sure this is at the beginning of the stream, so I can just tell people, hey, read my doc or watch the stream. That's where all the questions are answered. Okay. I've read the Teen Savers Live2D, said you can reverse engineer. I already covered that. I am not bound to the T and C for Live2D. FBX. Bytecode, blah, blah, blah. Metadata, MOC3 parameter evaluation. Yeah. So, that's what I expect. One of the things that is actually an interesting question is I do not know how to form. Oh, by the way, I'm not a rigger. I've never used Live2D Cubism. I don't actually know in any detail how rigs work specifically in Live2D. I've worked with other software that is not the same. I do not have detailed knowledge of how rigs work. I do welcome people in the chat who are riggers or have used Cubism. As a user, please do not, if you have ever decompiled any Live2D software or anything like that, please do not say anything. I don't want that information. However, if you're just a rigger, you've used it as a user, you're not doing anything weird, you're not violating any licenses, I do welcome people who want to explain anything about how the user experience of rigging models is, because that could be useful information for figuring this out, and I'm pretty sure that's legally fine. I do not know exactly how rigs work. However, I have a vague understanding of what I've seen in people who are riggers and how things work. So I know about deformers. I'm very curious to see how deformers are represented in the MOC3 file, because my thesis is that the representation is going to be a lot more baked in and low level than what you have as a rigger when editing in Cubism. What I would expect, and this is an educated guess, is that for things like linear deformations, like things that are, XY, that those deformations are baked into essentially blend shapes for vertices in the model, instead of being like overlays and meshes you put on top. But there are subtleties here, because someone mentioned that there are rotations, and rotations cannot work like that. So again, I do not have detailed knowledge of how Live2D rigging works, so I am only guessing here. It'll be very interesting, though, to sort of compare notes and figure out exactly what is in MOC3 and how it works. But yes, my expectation is that there will be, first of all, there's not going to be any names for anything other than the parameter names. We know the parameter names are there. We know obviously the art meshes, the list of them and stuff like that is there. And oh, by the way, the physics is already open. The physics in any Live2D mode, because I've seen riggers be like, oh, my physics setups are like so special, I don't want people to figure them out. I am so sorry to tell you this. The physics settings are in a JSON file that anyone can just open in a text editor and look at. For better or worse, physics rigs are not a trade secret. Everyone, if you think that people can't figure it out, they haven't tried, because anyone can look at that and figure out what the pendulum setup you have is. That is already wide open in a text file right next to the MOC3. The MOC3 only contains the basically parameters, meshes, and how they interact with every art mesh. It does not contain the textures; those are in a PNG file, and it does not contain the physics settings. And it does not contain the expressions or anything like that either. So those are all very easy things. I'm still going to work on that, in the sense that I need to figure out how to precisely document and replicate the physics engine that Live2D uses. Now, thankfully, I happen to have written a physics engine for a competing software that we will not talk about. So how do you figure this out? And so what I ended up doing is I ended up faking the settings that Apple's driver reads and seeing how it outputs these tables. And I did like hundreds of tests automatically, and then put it all into Excel basically, and graphed it and started playing around with formulas until I figured out a formula that does exactly the same thing that Apple's formula does, and the constants. And I used an optimizer and things like that. So, if it comes to that, I fully intend to do things like, say, take the VTube Studio, run it through a rendering debug tool that tells you that gives you like the GPU vertex outputs it's outputting, and take samples over time in frames and optimize until my physics engine works the same as theirs. So there are very interesting ways you can do stuff like that and sort of figure out formulas, or not necessarily the exact formula, but figure out a equivalent formula to compute the same physics engine, the same physics simulation as something without actually looking at the code and figuring it out. So yeah. All right, what else we have? MOC3, let's win. Yeah, that's Minecraft. All right, it's my first time here. Konnichiwa. Hi, konnichiwa. Result parameter range, and that's it. Yeah. I mean, like, there will be, I'm sure, I don't know how Live2D rigs work, but just kind of experience with similar things that are not Live2D. I assume there will be, like set points in the parameters, which then map to different parts and settings in the meshes and in the formers. And so then there will be essentially like tables, and you will be able to adjust like what thresholds the parameters, but at what thresholds of those parameters those things apply. And you probably will be able to have like, scaling, right? You'll probably be able to do something like change the range of a parameter and apply a curve to modify. There's also some things you can do, right? So there's going to be some information there that you can change, but it's going to be probably much lower level than what's in the original rig. All right. On DocX and Google Docs, actually, DocX is an open file format. The old school doc is the one that was reverse engineered. And then later, Microsoft released DocX, which is actually an open format called Office Open XML. And there was a whole flame war on the internet about that one versus the open document format. But in fact, both of those are open formats. So DocX is open, but the old school doc, that's the one that was closed. All right. And pure reverse engineering of the MOC3 file, you won't be comparing it to the original CMO3 file. That is correct. It might be interesting to take a peek at CMO3 someday if someone sends me one, but that's out of scope from what I want to do. I've gotten a letter from a cubist-in-law before. Well, as I said, thankfully, I have zero business or legal relationship with them. Thankfully. If there's a patent for MOC3 file format, we may not be allowed to read files but not write them. Okay, so this is a very subtle question. You cannot patent the file format. However, you can patent a technique that is required in principle, possibly, maybe, to actually use that file format. So when people say that the H.264 video codec is patented, what they mean is that there are patents on mathematical techniques and algorithms that in theory, you need to correctly play back an H.264 file. Now, that is not a guarantee. It is possible that, looking at the spec for H.264, you can come up with a different way of playing it back that still works and doesn't violate the patent. Now, that is a very, very subtle thing. I do not have any knowledge of any patents by Live2D. I haven't been looking. I don't want to look because that is itself could expose you to being more liable and if there is patent litigation involved. However, what I am very confident about is that just documenting MOC3 is not going to get me in trouble. Now, if I implement a MOC3 replacement and if I start distributing especially binaries of that, if there is something in there that Live2D claims infringement of one of their patents, that would be a interesting discussion to have. And I'm sure lawyers would have to be involved at that stage. But thankfully, that is a little bit further down the line. And I'm just kind of hoping that they're not going to, try suing a random person in Japan for violating their patents because they're messing around on GitHub. Because that's kind of unheard of. The only people that get sued for patent infringement for this kind of stuff are companies distributing, say, open source H.264 decoders without a license. Again, I'm not a lawyer, but this is really getting into the fringes of, what is scary or not, for a random person to be working on. Now, it is very possible that, for example, other companies will want to have nothing to do with my software, because they're afraid of, first of all, if people use my software and Live2D is angry, Live2D could say, we don't do business with you because you used my software. And, you may or may not be able to fight that in court, but they can do that. So they can at least try to do that. I'm not gonna fault anyone certainly any company, for not wanting to have anything to do with my software or what I'm working on in this stream. That's again, it's entirely legit to not want to be involved with this because you want to be on friendly terms with Live2D Inc., and that is perfectly fine. And I fault absolutely no one for making that decision. But that is primarily a concern for people who are Live2D customers and using Live2D technologies and engaging in Live2D license agreements. I'm doing this for myself and for people who just want to, modify their models. All right. And yeah, when I'm talking about all this, I am not a lawyer. I am by no means a lawyer. I have spoken to lawyers before about these topics in the past. I may or may not have been involved in a legal action before related to this kind of stuff. I know lots of people who know a lot about this stuff. I have involved myself very deeply in conversations of how all the legalities of all what I said works. So although I am not a lawyer and I will get a lawyer if I need to, I do know quite a bit about how it works. Okay. Yeah, the customizable models and removal of the stuff you don't want. That makes sense, right? That's the most obvious thing. All right. Blender plugin, that's a very good question. Actually, I do believe that if we're talking about creating models from scratch, Blender would be a very good base to work on, because at the end of the day, and I'm going to make a very big generalization here, 2D model rigging is like 3D model rigging minus one dimension. A very big generalization here. I know it's a little bit different, but at the end of the day, things like creating meshes of vertices and textures, those are the same. The main difference is, and the trickiest part with Blender, is that rendering 2D models is not the same as rendering 3D models. And so you generally cannot use a 3D rendering engine unmodified to render a 2D model. And the main reason is you have things like masks. Masks are the big thing that just doesn't translate to the rendering engine that Blender uses. So generally what you would need is a custom render pipeline or sub-pipeline that does the preview and is involved with actually rendering the thing. But you could totally use Blender as a base UI for editing VTuber models. You would need a bunch of things on top to implement things like, whatever you call deformers and all the editing tools that makes it convenient to do things that are important in 2D that you wouldn't normally do in 3D. But I think actually that, yes, Blender would be a very interesting baseline, a very interesting, thing to build on top on if you're building a 2D model editor. So yes, a Blender plugin. All right. Yeah, the customer may not use the output file, but software or middleware to compete with or could compete with. That's not transitive. If you are rigging something and you use it with my software, Live2D might be able to say you're breaking their license. I personally think that license term is kind of ridiculous and probably not legally enforceable, but that's for lawyers to argue. However, that certainly doesn't apply to me because I am not using their software. And riggers are not required to forbid their clients that they give the model to from doing whatever they want with the model. So, you know, if Live2D thinks that by putting that in their license, they can stop anyone from ever combining Live2D models with anything that competes with Live2D, that's not how the world works. I'm so sorry. Like some of the stuff that Live2D puts in their license agreements is honestly very like, what are you guys doing? Like, this is not how. If someone with money wants to fight these things in court, I'm pretty sure they will be able to, because some of the things in the Live2D license are ridiculous. But that's not me, and I don't have to care because I have not agreed and I'm not bound by the Live2D license. Okay. Going down, open source. Oh yeah, I heard about it. It's like there's Java, and the HTML3 files are just like serialized Java objects or something. Anyway, scrolling down. Where am I? Suddenly the chat updates and I get a lot more messages. Okay. I can make a conversion feature, so it can be moved between Live2D and other stuff. As I said, maybe eventually, but it's unlikely that any existing technology will map to Live2D. So rather, I think that an alternative to Live2D needs to be built either to begin with or built up towards full compatibility with MOC3 for that to make sense. Oh, it froze for a sec? I'm so sorry. I'm so sorry. What was missed? Because I don't know what happened. I heard nothing here, so I think my recording is okay. Because normally when my stream machine craps out, my audio stops, but I noticed nothing. Is it possible that Live2D rearranges the RAM for saving to MOC3? It's relying on RAM usage of Live2D. I'm not sure what you mean by that. But it's not a RAM dump, for sure. And then, yeah, by the way, about trade secrets. Like, if someone mentioned that, the MOC3 file format can be a trade secret in the sense that if you are a Live2D employee and you learn about MOC3 files, and then you tell someone else, you're breaking the law. However, trade secrets protect people from industrial espionage. Trade secrets do not protect you from other people figuring out how it works. Once I figure out how MOC3 works and release it, it stops being a trade secret. Like, I will cause it to stop being a trade secret. That's how it works. So that's not something I have to be concerned with. All right, I'm catching up on the chat. Internet dropouts, that's so weird because like everything's wired here. Unless, if it happens again, I hope you tell me. Maybe I need like a monitor or something. OBS says 0 frames dropped. Yeah, it says 0 network frames dropped, so I don't know what happened. Maybe it was the YouTube side. I don't know. FTC doesn't like this. Could they pressure V2 Studio to update the terms to forbid use for black box testing? Yes, they could. But that would not retroactively apply to existing versions of Live2D, of VTube Studio. And VTube Studio runs outside of Steam, and they certainly don't force you to update VTube Studio. And I have a copy of VTube Studio on this Mac. I don't even have Steam installed. I just copied it from another Mac that does have Steam. So they could do that, and they could make it difficult for new updates to MOC3 to be reversion engineered that way. But they're not going to stop me from figuring out what currently exists. So if that happens, we'll see. But honestly, I think it would be quite ridiculous for Live2D to go telling Denji, "Hey, you have to add this to your EULA." That would just be so sad. That's kind of the direction they want to go in. I hope they can try to be, team players and this kind of thing, and just kind of don't go crazy like that. But we'll see. Yeah, exactly. The Coca-Cola example is like if you make an imitation Coca-Cola until you come up with the exact same taste as Coca-Cola, you're not guilty of stealing their trade secrets. You just figured it out yourself. It's the same story. And people have, I'm pretty sure. I mean, this is kind of a myth that the Coca-Cola recipe is this uber secret. I'm pretty sure people have figured out how to make things taste like Coca-Cola, and it's it's been done. It's just a kind of urban myth, right? This is secret thing. Like, I'm sure the original recipe is still a trade secret, but it's not like nobody can copy the Coca-Cola taste. Okay, so I think that's it for all the intro stuff I wanted to cover, and we are an hour in, which sounds about right. For this is a very complicated topic. We have 190 viewers. That's a lot. So time to get started, and this is gonna be interesting. So I think we are ready to jump into the story. And hold on, what is this? Let me just fix something first. Okay, good. So how do we get started? Well, first of all, we're gonna need a hex editor. So let me get some files out and make sure that I'm safe. So this is actually the first stream I do from macOS, because I've been using macOS recently. So I actually am not fully comfortable with developing on macOS yet, so this is also a bit of a challenge for myself. But do I have my NAS mounted here? I possibly don't have my NAS mounted yet. Let me pull some stuff here. Okay, now it's mounted. So in theory, I have my model here. We're gonna use this one. I think. Is this the VTube Studio one or the? Hold on. I think it's this one. No. Yeah, it should be this one. Okay. So this is the one I'm using right now. And as you can see, let me make sure this is, if I can get my keys right. So as you can see, let's look at what actually goes into a model, because VTube Studio models are actually, those are junk. VTube Studio models are actually a bunch of files. They're not just the MOC3. The MOC3 is the black box, but there is more stuff. So for one, the textures are just there. They are just PNGs. So the textures are completely separate. You can already edit them, do whatever you want with them. There's nothing locked down there. They are texture atlases. So you have to draw within the bounds of the original texture, but there's no mystery there. Outside that, the expressions, these are VTube Studio expressions. Again, there is absolutely nothing secret about these. It's literally just parameters and what you do with them. That's it. Similarly for pins and other random stuff. And the VTube file is also just some random VTube Studio things with positions and parameter settings. And again, this is all boring stuff you can do in VTube Studio. There is nothing interesting. There's nothing secret or interesting about these. So this file and the expressions and all that would be things that you would load into a playback tool like VTube Studio, like high-level VTubing tool. There's nothing here is anything that we are particularly interested in for the purposes of reverse engineering. Now, there's a Model 3 file, which is the high-level model configuration, and that is just references to other files. So we have the MOC file, the 3 textures, the physics file, a display info file, which I actually don't know what that is, and some groups of parameters. Looks like this probably just merges or groups. I think it's probably just grouping for visual purposes of the parameters. I don't know. Seems kind of boring. But this also tells us that these parameters, like term open, that has to be inside the MOC3 file, because these are strings being referenced. So these parameter names have to be in the MOC3 somewhere. So that is important information to know. So what about that CDI3 file? I actually don't know what that is. So this has, okay. So this has parameter names. Okay, so this is mapping the parameter IDs, which are just, which are apparently just, okay, so actually I lied, and that name might not be in the MOC3 file. That name might just be, maybe, hold on. No, they do. Okay, so yes, sorry, they have to be. So this is apparently just giving user-friendly names to the parameters. So it looks like we have parameter groups, and this was rigged by a Chinese rigger, so the names are in Chinese. I've actually never seen these in VTube Studio, so I'm guessing VTube Studio doesn't use these. Or I just didn't check. Oh, thank you so much for the 50 memberships. Oh my god, you're crazy. Thank you so much. Thank you, thank you. Thank you so much, Cassidy. Thank you so much. That's a lot of memberships. Thank you. Okay. It keeps going. That's a lot. And now I'm seeing who's here, because like the Comex is here. I don't think yeah, he said anything. I know that person. Yeah, that's like 25% of the oh my god, thank you so much. Thank you so much. Okay, so yeah, this looks like this is just giving friendly names to some of the parameters and grouping them. And that looks like it's mostly, there's angle rotations. Those are probably used for the physics. So yeah, this is just friendly names for the parameters and groups. And it looks like we have parts. I think those are the art meshes, which are the individual, essentially layers of the PNG, of that PSD you would use in a model. So I'm guessing these are friendly names for those. So this is very useful because it gives us some info, though everything's in Chinese. So I might have to run this through a translator to make some sense of it. But also the IDs here have like art mesh 99, part 42. So these strings still have to be in the MOC3 file, I think, unless these are constructed. And then finally we have the MOC3 file, which is the big black box we don't know anything about. So I can actually just hex dump it and we can take a quick look. Parent groups are actually UI feature Live2D. Yeah, that was my assumption. What's the icon between Firefox and settings? Oh, that's Nico, which is a matrix client. And actually, I don't know why this is here because it's not supposed to be pinned. Okay. Mostly because I don't want to click on my social media by accident, then, or my like IMs by accident, and open it during the stream. So, okay. So the MOC3 file, yes, we can just text dump it, and we'll see there's stuff in here now. Yeah, there we go. So you can already see some stuff. Just literally scrolling through a hex dump. A hex dump is a representation of every byte of information in the file. First, anyone who's messed around with reverse engineering knows what this is, but for those that haven't, this is a representation of every byte of data in the file. This middle part has the actual data in base 16 in hexadecimal. The left column is the address, which is the number of the byte in hexadecimal. And the right side has a text representation, which is useful when there are pieces of text in the file. And as we can see, just scrolling down a little, there are all our part names right here. So no surprise there. And those look like some kind of deformer names. So that is interesting. And the art mesh names, which again are just numbered like that. So this is just recon. We're not reverse engineering anything, like, what's the word I'm looking for? Methodically here. We are just looking around, see what we find. So I am seeing a lot of arrays of things. I'm seeing lots of similar numbers grouped together. And here are the parameters, parameter names. Oh, and I forgot to look at the physics file, by the way. I think I forgot. So yes, the physics, before we look at that, the physics are just in a JSON file. And everyone who's looked at riggers working on stuff has probably seen the pendulum rigs. That stuff is all here. You can see that they are, for example, there's physics setting has an input from a IOpen parameter. It tells you these settings, which I believe are just in the UI in Cubism, and it tells you that they output to different parameters. And then they have, this is probably a chain of pendulums. It tells you there is an, some of these look like maybe they are duplicates. And they have vertices. Yeah, so these are the mappings between the pendulums and the output parameters, and these are the actual pendulums in the chain, with positions and parameters on the physics and all that. And I believe you can actually re-import this file into Cubism and to reapply physics settings. So riggers, you should know that your physics are already out in the open. There's nothing secret here. The only interesting thing about this file is going to be precisely defining exactly what these numbers mean and how to interpret them to run physics in exactly the same way as Live2D. But that is not going to be, it's going to be an interesting task, but there's no black magic there. So yeah, all the physics are just right there. All right, back to the MOC3. So yes, there's lots of there's lots of strings. I see numbers. I see floating point numbers. I see lots of stuff here. So now we could look at it like this, but this is going to be very tedious. There are two ways. I would usually start working. In the past, what I've done is I've started working with this kind of hex dump, and then writing a Python script to slowly work out the file format. However, I want to try something else. There's a hex editor called mhex that is kind of interesting, and this is the weird web version. And I want to try using this. I don't know if I'll get used to it, but I want to try using this tool. So this is a hex editor that is designed for reverse engineering or editing file formats that you're not necessarily familiar with. And yes, I am going to be just looking at my model. So we're going to try using this. Let's... Oh, no, one of those. Okay. Give me 1 second, just make sure I don't show anything weird. It's not notarized. Alright, so here we have him hex. How do you realize a variable is an array and a floating point from hex? I will go into that. So I'm going to try to make this first stream kind of educational about file format reverse engineering. And instead of kind of going into hyper-focus, you know, figure it out mode. So I'm going to try to make at least this one and maybe the next one, you know, more like accessible to people who are not particularly experienced with this. So I've only used this once in a test stream I did with Cyan at one point, so I cannot say that I am particularly familiar with this. Let me see if I can make it a little bigger, because otherwise you won't be able to see. Where's the settings here? Quick settings? No, give me all settings. Interface. There we go. Scaling. All right, I think you can probably read this. If you're not familiar with my streams, I try to make things readable, but I do expect everyone to watch who is interested in seeing the details to watch in 1080p. So if you're not watching in 1080p, please do so, because it is simply not reasonable for me to work and also show things, you know, like 720p compatible. I think I can do a little bit bigger. All right, let's go with this one, because I do have the global macOS interface settings set pretty small, so I can fit more things in my screen normally. But for streams, I will I'll make it a little bit bigger. So hopefully this is mostly readable. Okay. 220 viewers, that's a lot. All right. I think I know who made this logo, because this is the VTuber logo meme template stuff. I think I know who that person is. All right. So, I'm gonna make a copy of my project here. Let's make a NAS. Do I want to do this in the NAS? I probably have the Git in the NAS. Yeah, I can work in the NAS. Okay, do I have a dev folder here? Yes. MOC3 RE. Let's see, MOC3 RE. And let's make a complete copy of my model. In here, so I can mess around with it. We'll figure out Git repos and stuff like that later. So let's open file. Close that. Try to make sure I don't, because I usually don't have anything weird in my NAS. I'm being a little paranoid just to make sure I don't. Actually, give me a second. I'm gonna make some shortcuts. Sorry, I can just go to this one. So again, I kind of just started doing all this stuff, so I don't really have macOS particularly optimized for anything, but I'm gonna just bear with me for a second. Oh, that's not what I want. Oh yeah, that should be fine. Alright, I think I'm good now. Alright, so back to this. I just made some favorites, so I don't have to keep clicking through all my paths. So MOC3 here we have this model, and I can just hopefully the hex thing. What just happened? Let's try that again. Open file. Why can't I click on dev? That's very strange. That sounds like a bug. Why is it not letting me... Why is it not letting me click through my... Why is it letting me click... Wait, now it is. No, it's not. Wait, what? I don't know, this is really glitchy right now. What is going on? The open file box does not work? What? I actually can't click anywhere. What the heck is going on? Let's try that again. Hold on. I'm just gonna switch again, just... Just give me a second, because I just want to make sure in my flailing around to figure... Okay, restart fixed it. Okay, a restart fixed it. Okay, we're good. That was weird. Okay. So yes, here's our model file. Let's open up this MOC3, and I can probably save some kind of project file. Can I do that? Save as? No. So save project? I'm not sure. As? Can I create a project file? There's open project. But I want to save a project. Whatever. Wait, I just opened this and now there's no hex view. This is a little bit clunky already. View hex editor. Okay. File. Is there a save project? Oh, project. Save project as. Okay. I keep forgetting that the macOS has a title bar at the top. Okay. There we go. Now we have a project file. So the cool thing about this hex editor is that you can write essentially scripts that that describe how the file works, and then it will convert it to essentially a tree representation. So the idea is that we document our file formats in a special programming language that it's not a programming language, it's like a description language that tells imhex how the file works, and then it will apply that knowledge to the file and break it into a structure, into a high-level structure that we can make sense of. So eventually I will be doing this in Python using a library called construct, which is my favorite for this. However, I think it's nice to have a visual, tool, and especially if I'm going to be explaining how this works, I think this is going to be a lot better than me messing around with Python and construct from the beginning. So we are going to try this. So let's look at the beginning of the file. Okay, so the first thing we see is MOC3. That is something called a magic number, which is just a number or string in this case that identifies the file. That is always going to be constant. The next thing we have is a pile of zeros until hex 40. Now, and when I say hex 40, by the way, this means 64, because all these numbers are in hexadecimal. When you're working with file formats, Most often things will be aligned to multiples of various powers of 2, which makes hexadecimal much nicer to work with. So we're going to be working with lots of 16s and lots of 128s. And when you read those as 10 and 80, it's much easier. So I'm going to be speaking hex. That's how everyone does it when we talk about these things. So just keep in mind that pretty much any time I talk about a number, unless I specify that it is decimal or I am counting up, I'm going to be speaking in hex. And you're right, it's MOC3 and the 5, and the 5 is probably a version number. So that means we can start writing the parser. Now, one interesting thing is that, as I said, this has MOC3 of 5. MOC3 is a ASCII string, which is stored as these 4 bytes, and then we have a number 5. And that's just a byte 5. Now, it's reasonable to assume this is probably a 32-bit integer. Doesn't really matter, but we can call it as such. Numbers in files are usually stored in one of 2 ways. You can either store them starting with the lowest byte first or the highest byte first. In this case, and in the case of most computers, you store them backwards with the least significant byte first. So in this case, this 5000 would be read as 0005. And you can see that here, and when you interpret these 4 bytes as a unsigned 32-bit integer, you get the number 5. I'm gonna make some space here. So, well, these 4 bytes here, these are an ASCII string. And you can see that interpreted as a string. They just spell out MOC3, which is obvious because we can see the same thing on the side here where it says ASCII. So we have this constant, which is going to be the same for every file. This 5, which is most likely a version number, because that usually comes after magic numbers. And then we have a pile of zeros. So why are there a pile of zeros? Well, this is not that common, but it's common in files that have to do with graphics and GPUs. This is called alignment. So what this is doing is it's making the next section of the file start a multiple of a power of 2. In this case, that power of 2 is 64 or hex 40. Why would you do that? Because a lot of operations in computers, and in particularly GPUs, either only work or are faster and more efficient if you align the starting address or the beginning of the data to a multiple of a large power of 2. So in this case, I am expecting that to be a pattern because no one does this for the magic number and then doesn't do it again. And it's fairly common for to have some header data that has some extra space just for expansion purposes. But this number, after just a magic number and a version number, is telling me that it's probably intentionally aligning the next section of the file to a power of 2. So what we can do, and I'm going to have to read documentation for this. So let me find the imhex docs here. Where's the docs? I assume GitHub has a link to docs somewhere. Read docs. Or page. Yeah, some people call it pages, but pages are usually larger. And if you want to get technical, a number on the order of 64 is usually a cache line in many CPUs. So pages are usually larger than that. They will be either 4 kilobytes or 16 kilobytes, or in some file formats that are organized in some sort of page structure, you might get like 256 bytes or something like that. But we generally don't call a small number like this a page. We would refer to that, if there is a technical reason for it, probably as a cache line. However, in terms of the file format itself, it doesn't really matter what you call it. It doesn't really make sense to give it a name unless the person that designed the file format has, like, you know, when you design file formats, you get to pick the terminology, right? So that means that when you reverse engineer file formats, you get to pick the terminology that you use to describe it. I have no idea what Live2D calls anything about a MOC3 file. I'm going to make up my own names for everything. But yes, a word is usually a small thing like 4 or 8 bytes. A page is usually a fairly large thing like a few kilobytes. And yeah, something like 64 bytes. You could variously call it a cache line, a block. It depends on what makes sense. But in this case, I would just say sections in the file are 64 byte aligned. So, because also in this case, like a page makes sense when you have multiple pages and each individual page has some structure. However, here we see that's not the case. This is aligned, and then we have a bunch of data after, but there's nothing splitting up the next 64 bytes, the next 64 bytes, the next 64 bytes. There's no pattern here that is that makes these individual blocks stand out. So it's not that there's a page that has a relevance in the file format. It's just that each individual section, and that is a common term, a section, of the file is itself individually aligned. A lot of file format reverse engineering is just visual patterns. Like even without explaining to you what any of this data is and what it likely is, and I have my ideas, you can probably visually see that there is stuff that starts here. Every 4 bytes, there is some kind of item. And then it goes down, and it just keeps going. And, you don't have to know much about reverse engineering to be able to visually see that pattern. A lot of file format reverse engineering is visual pattern matching. And humans are good at matching patterns. So, let me... pattern language, yes, that is what I want. So I don't know if they have, some kind of alignment thing going on. There's a whole library for that aligned to, that's, I guess... Okay, it doesn't really matter because, let's see, attributes. This is it's inspired by Rust, and it's very rusty the way this is designed. If you've used Rust, you probably recognize the syntax. It's very Rust inspired. Alignment, that's for bit fields. Okay, no. We're going to ignore the alignment issue because the alignment issue is mostly an issue when you are generating files, and we are, at least right now, mostly interested in in understanding the file. So we're going to be writing a file parser first, and then later a file generator. So we're going to ignore the alignment for now and just say that first we have struct header, or even just version header. And that structure is just going to have a magic number. There's probably a way of doing strings magics. Let's see. Data types. Car. Yeah, we can do car. And how do we do? So we can say car for magic, probably. And we need a semicolon at the end. And then we can say version header at 0, because it starts at the beginning of the file. That did not work. God separator. Does this have to be after magic? I'm guessing here because I've never used this language. No, it doesn't. Oh, not that's. Wait, what? Oh, sorry. Needs a name. There we go. Okay, that works. So now we have a version structure that is 4 bytes, and it has a field called magic, and the string has a value of MOC3. So this is defining. We can delete the example here. Let's keep this IO thing and this print. I'm probably going to be using that. So that declares the structure of the file at the beginning. Starts with a 4-character magic number string, and then has a version number. So we do that. by just saying, we're going to assume this is 32 bits. This is a educated guess. It does not really matter. The version number is not going to be, more than 1 byte. But it's just, my guess as an engineer is that Live2D declared this as a 32-bit number. So now we have 2 things, a magic and a version, and it nicely color codes them for us. It's a language similar to C. It's actually very similar to Rust, which itself is inspired by languages such as C. So, if you use C, you'll recognize some of these things. Strictly extending to probably some offsets. Yes, you're getting ahead of myself. I know that. All right, so we have the version header, and now what's going on here at 40? Well, yes. If we look at these numbers, now we can look at the decimal number 1984. That's interesting. That's kind of amusing. You can see that they are increasing numbers. You can also see that visually. The second byte is counting up by some amount, not a consistent amount. And the numbers here are, if we look at the orders in the thousands, if we look at the bottom of the file, and this is an interesting thing you can do, is you look at the last number. The last number is about 21,000. Now, one question we can ask ourselves is, how big is the whole file? The entire MOC3 file is about 3 megabytes. So, sorry, not 1,000. The entire MOC3 file is 38.22848 decimal size. And the last number in this list of numbers is actually the exact same. Which means this is the size of the file, and these are offsets or addresses into the file. What we have here is a table of contents. It's the same thing as a book. In a book, you have a table of contents, and then you have page numbers. In a file that is arranged like this, we have a table of contents, and then each one is a byte number into the file. And interestingly, the last one is the file size. This is not required. You could just not have that and not lose any information. But the fact that that's there means that whoever designed this explicitly wanted to mark where the file ends, or it could be 2 things. Or that there are sections at the end of the file that are empty. And if we look here, that one's also the file size. That one's also the file size. So that tells me that there are sections at the end of the file that are actually empty. And that's why they're all the same number. Most likely. Another interesting thing is that we don't have any lengths. Each chapter, each section of the file doesn't have a length. Now, there are 2 ways this could play out. One is that a section implicitly ends where the next section begins. In that case, you would just take the difference between the byte numbers of 2 sections as the length of the previous section. Another way this can play out is if the section itself has a length built into it somewhere into the section data. We don't know any of that yet. We will find out. But these are kind of the options, when you design a file format. Now, this file format also, the way it's designed, it tells me that this is, how do we call it? Like, it's kind of an array of structures. A structure of arrays file format. And it's actually relatively rare to have a file with so many numbered sections one after another. More commonly, you get files that read more like a website, where you have data in some kind of hierarchy. Like you have like a page, and then it has a thing at the top and a thing at the left, and then it has some components, and that has some text inside. You have a hierarchical file format. It's pretty common for anything that has to do with text. It's pretty common for things like, say, vector graphics, where you have groups of items, and otherwise it's also fairly common to have like a header that has a bunch of mixed information, including offsets to things and actual data. But this kind of table of contents approach with a lot of sections is relatively unique, but makes sense in the context of graphics, because it is possible, now not guaranteed, this is just a wild guess, but it is possible that this file is designed so that parts of it can be directly used by GPU rendering code. That means that there will be things organized in here so that they can be directly accessed by a GPU or shaders or GPU code or things like that. And that explains, the alignment explains why it is designed like this, because this is very common in game development, but relatively uncommon elsewhere. And yes, discovering unsafe formats here. So I'm not going to go into security because that would be too much of a tangent, but there is absolutely things you can do to this file that would make it weird and broken, and that could crash the software, or, you know, you could discover security bugs. We're not going to go into that because that is a little too much. But absolutely, there are ways of making a file that makes no sense and that could do interesting things. So now that we have this table of contents, what we need to do is actually read it. And there's a couple ways we could do that. We could just declare a structure with all the names of the fields that are these starting offsets, or we could just have an array. And because we don't know much yet, and it's going to be really annoying to type things out, I think what I'm going to do is I'm going to just declare this as an array. Now, I'm assuming that this array of sections is fixed, that there's a standard number of sections the file may have, because there's no length at the top, there's no end marker, and these sections, as we looked before the hex dump, they contain different things. They contain names, they contain other data. This is not a list of same things. This is a list of different things. And when you have a list of different things, that means that you need to know what each thing is. And if there is nothing telling us what each thing is, then the only reasonable thing to assume is that the list is always in the same order and has the same number of things. So we can literally just say, let's make it a struct just to be safe, but actually no, we don't even need to do that. So how many things do we have? Well, we start at 40. We end at 2A0. Subtract those. You get 260. Divide by 4. You get 8 plus 188. 1. No, I'm just trying to do mental math. I'm trying to show off a little too much here. 2A0 divided by 4. Is there a calculator or something that we can use here? Well, we can probably just write it out actually. So 2A0 minus 40, I can do that in my head. That is 260 divided by 4. Does that work? Sorry, U32. So now we have a list of offsets, and those are just numbers. And so now I would like to start documenting what these structures are. Now, there will be some of them that are specific structures, like ordered in different ways. We may not want to necessarily figure these out in order. There's a lot of them. Like, this means there's a lot of things to work out about this file. Like, we have to go through each one of these individually, because they are different things. It's not a list of uniform things. We can just say, oh, that's that, that's that. No. We have to go through every single one of these to figure out how MOC3 works. So obviously, I'm not going to finish this today or anywhere close to today. We're going to start, though. We're going to get started in the beginning. Hopefully, just kind of logically, we start with simpler things, because people who design these files probably went through in order, right? And usually the more basic things are at the beginning and the more complicated things are at the end. So you can also see there's a big jump here, right? From this address to this address. That means there's one huge section that is most of the file. And my guess is that is vertex data, because that's either vertex data or something to do with deformers, because that is most of what the bulk data in the file is going to be. But it is interesting. So let's start by documenting what these sections are.
Oh, what?
Oh,
Hi.
Cyan just showed up and like surprised me. Got you lunch. Okay. So I'm gonna have some lunch actually, and before we continue, let me check the chat. And if you have any questions, let me know because I can answer. And I figure things out. Right? Wait, Cyan? I need chopsticks. She just gave me a bento with no chopsticks. What? Okay, thank you. You send an open bento and then nothing to put it on the chopsticks.
Because you have chopsticks on your bed all the time.
That's the other room. It's not here. I've said this is zero terminate, but that actually doesn't make a lot of sense because if these were a list of same things, then you would expect them to kind of terminate the list. But they're not. We know there are a list of different things, and so there has to be a fixed number of them, at least for every version, right? Version 6 might be a different number. Version 5 has to be the same number of same things in same order, so you don't need a terminator. Thank you. Can you bring me that little table thing that you have on your side so I can put it on there? Okay. Well, I will eat. Please feel free to ask questions. I hope this made sense so far. I guess that works. Partially.
I will take a look.
Yeah, you can close it.
Partially. Now you don't have oxygen issue.
Probably not.
Very good.
You have models to compare. I do have Science, which is interesting because it is it's one of those template models where we both got models based on the same base rig. So that'll be an interesting diff with hers at some point. But for now we're just gonna look at mine because there's a lot you can just guess visually. And there's different techniques. Part of it is just looking at a file blind and seeing what is there, and we can find out a lot just from that. But we will need multiple files eventually to figure some things out. It really depends on how it plays out, and we won't be able to figure everything out. There are going to be things that I need an example of because these files are not going to use every single feature. So there is never a guarantee when you're versioning your file format that you got everything, right? But that's why it's an ongoing process. I become you. What did you study? I mean, I did computer science, but most of this I learned on my own, just messing around on the internet. So I think anyone can learn this kind of thing, just kind of through self-study. Is there any special method you made for yourself to self-study? Not really. I think the best way to learn reverse engineering is actually just through a project. Pick something simple to reverse engineer, and I realize that's hard to know if you're new, but just try something. Even if it's a file format that already exists, just, without looking at the documentation, pull it up in Impex and see if you can make sense of it. A lot of file formats are very simple. MOC3 is going to be a pretty complicated beast, I expect. Not, as complicated as something like a Word document where there are infinite features and things going on, legacy, but it's going to have a fair amount of weirdness to it, and it's actually going to be very difficult to figure everything out without some knowledge of how people rig models, which is why at some point I expect to be looking up online documentation and videos on Live2D Cubism, because I don't want to run the software myself, but I do want to see what other people are doing with it and learning about how it works. But yeah, this is a pretty big project as far as reverse engineering file formats work. But there are much simpler file formats you can start with. Can hang out because work. Thank you so much for the work you have done so far. Thanks for doing. Thank you so much, Cyan Nyan. Yeah, another thing that, of course, you can do and you should do is, before reverse engineering a file format, look at an existing file format, learn how it works, and write tools to work with it. It's something that is documented, because that will give you the knowledge of how file formats work, how they can work, the techniques behind them. And so once you're familiar with some file formats and how to interact with them, how to write code to work with them that are documented, that's when you should go and try reverse engineering something. Okay, I do into having others who do have a Cubism license to produce files doing specific things, specific features. If they are comfortable with that, I think, if anything, they are undertaking the risk if they do that, not me. So I would be open to that, but I have to say be careful, because Live2D could just say, well, we're never licensing you an update, or we're revoking your subscription or something like that. How do you deal with the dread of assumption when you can't assume something when you don't have enough data? You have to get over it. You have to make assumptions all the time when you reverse engineer file formats. You should be trying to document what is an assumption when you're not sure. Sometimes you don't know what something is. You just say unknown. You will see. Today, you will see the word unk so many times. Because by default, you don't know anything. But once you have an assumption about what something does, you just have to roll with it. If you are not sure, you can say maybe. There will be probably things in the description here that's like foo maybe, and that's a mental note that I'm not sure. I need to consider that might be wrong. And sometimes you discover that something is wrong and works in a completely different way to how you thought much later on. And sometimes you waste hours trying to make sense of something until you realize your assumption was wrong. And that's just how reverse engineering works. There's no trick to it. You really just have to get used to it. My avatar's glasses always not worn. It's just like that. I used to have them on in my previous model, and then Cyan likes me without glasses, and then we figured out that the forehead thing was cool, and it just kind of happened. I do have a new model coming up. This is a kind of BYOC type of rig. It's not a from scratch model. But it's really cute. I like it. But I do have a really, really, really nice complete custom model coming up soon. So it's really good, and I hope you'll come to see it. That'll be a debut at some point. Almost certainly this month. So look forward to that. 260 divided by 4. That's 2A0, which is the end address, minus 40 is 260, and divide by 4 because each element is 4 bytes. So this is the length, and since it starts at 40 and ends at 60, that's what it works out to. I've tried working with Cubism in Linux. Now, as I said, I have never used Cubism, and for my own safety, I will never use it. At least not until this project is like well and truly figured out, and even then. Okay. At the license, say if they revoke your license, they destroy everything you made it. I don't know what it says. Honestly, that kind of license term sounds like absolutely ridiculous to me, and I think if someone actually tried to enforce that against someone that has a minimum amount of money for lawyers, they would get struck down in court really bad, because quite frankly, some of Live2D's license terms are just completely insane, and I'm pretty sure not enforceable in a court of law. That's kind of the other reason why I want to do this, because I think they do need a little reality check on that. I'm so sorry, but their licensing is just insane. Anyway, as I said, good thing is I'm not their customer, so I don't have to care. You figure out the license for yourself and use it Live2D because you figured it out, so definitely legal problems. I don't know. I haven't read through the fine details of that, but yeah, they banned you from like supporting competitors and the thing. It's honestly, it's really crazy. I don't know whether lawyers. It kind of sounds like their lawyers think that they can just write anything into a license and anything goes. Like, it's really, really anti-competitive and crazy. And nah, I'm sorry, that's not how the world works. But I'm not a lawyer, and as I said, I'm not going to be the one fighting them in court for those crazy license terms because I didn't agree to the license. So, all right, let's get this going. First question: where does this array end? Well, the first address is 7Z0, and sure enough, at 7Z0 we have something. Why is it 7Z0? That is a very good question. I don't know why there is so much padding, is what it's called, at the end of this array. It could just be for future expansion, because they want to be able to add sections without changing this length of this section. It could be something that I don't know about. It could be legacy. It could be that I am wrong about this being a fixed length array, and there are sections, there's some way to make sense of this in terms of a list of sections that are the same in some form. I do not know. I do not have an answer to that. We don't have to care for reading the file, because we're just gonna, this space here could be not there, and it wouldn't change anything about how we read the file. So, first section here, what do we have? This is a big question mark. We have a bunch of numbers. They are mostly small. 62, 241, 164, 77, 169, 162, 62. And then we have a bigger one, 18, assuming this is a 2-byte integer, we have a 1,874, 385. Now, I can start taking guesses here because 1,874 and 385 are plausibly dimensions. Now, I don't know if that's the case. I don't even know if there's a way to get some kind of overall dimensions from Live2D about... Hey, yeah, you know what? Let's take a little detour before we do that. The VTube Studio has an API that I cannot type. And that will give you some information about the model. I don't know how much. So there's getting the currently loaded model. This gives you some information. Most of it is not very interesting. Number of parameters and art meshes, well, we can guess that from the string lengths anyway, so that's not terribly important. So this is not, I'm not that interested in that information. Does it have anything about the model? Model move, hotkeys. Let's see. Get a list of art meshes, but we know that already. They have tags. You can tint them, but that's... I don't think there's actually anything in here that we really need, that would be useful. Yeah, you can get the values of the parameters. Custom parameters, that's for... What is that for? That's for... This is for users to select them for the tracking, so that's not very useful. All right, they have some stuff about physics. Now, the physics stuff might be interesting because I suspect that by playing around with, we can get parameter data from VTube Studio, and that will let us get the output of the physics engine in some ways, which will be interesting for reverse engineering how the engine works. But that'll be much later. So I think right now we don't really have anything interesting to get from VTube Studio. So I don't know what these are. Now I can at least get the number of art meshes and stuff just by looking here. So let's do a very quick thing in the terminal before we get here. If I just run a thing called strings on the MOC3 file, it'll give me a list of textual strings in the file, as you can see here. And we know we have all the deformer names and art meshes and stuff in here. So I'm just going to dump this into a strings.txt file. And I'm just going to separate these out because this will be useful just as a general reference. So we have params.txt, art meshes.txt, deformers maybe.txt. So these are the parts. Is part of part 30? Yeah, probably. So these should be. Remember we saw these earlier. You have these parts, right? So I'm just going to pull these out ahead of time because that way you can get numbers of them. So we have a number of strings here, and it ends in the skinny one. So I'm just going to take these out and put them into separate files because this will be useful as a reference. So we have params, we have warp. These look like deformers, and it looks like there's two types, rotation and warp, which is useful information. So these will be deformers. Then we have, looks like we have parts and art meshes, and they are possibly different things. So let's call these separately, actually. Let's call this, how do we rename this? No. There's no rename. There's no rename thing in Sublime. I guess because macOS lets you just do that anyway. Art meshes. Let's rename that to parts.txt. And it did not like that. Don't save file. Okay, so whatever we call these parts, maybe parts and art meshes are separate things. I actually, as I said, I don't know too much about Live2D, so art meshes seem to be separate things. Let's take these out. Art meshes here. And then we have parameters. So parameters. And that seems to be all the things. Now this is I think there's no more interesting strings in the whole file. Yeah, all the strings come at the beginning. So we can just close this. Now, the reason I want to do this is because I bet this number is somewhere. So if we go to the beginning where we were, 62. Do we have 62 of anything? Parts! 62 is the number of parts. Now we know what this means. This is the number of parts in the model. So this looks like it is a global header containing, important top-level information about the file. Let's call this model header. And we have num parts. The second one is 241. Do we have that? Deformers. I think I forgot a new line in there. Deformers, probably, yeah, it doesn't have a new line, so that is the number of deformers. See how a lot of this is experiencing guessing the right thing? Like, I see small numbers and I'm like, that's the number of something. That's either a count or a small dimension or something like that. And so it makes sense. We know there are different things in the file called parts and deformers and stuff like that. So see if it makes sense. The next one is 164, which is the number of parameters, and I am off by 2. Or the number of art meshes, and I'm off by more. Hold on, let me check the parameters, because I saw... parameters start at... First one is param. And the last one is this angle rotation 57. So I do have all of them. So we have a, that's the first strange mystery. Can I create bookmarks? I bet there's, yeah, let's create some bookmarks here. How do I access bookmarks? View bookmarks. Can I rename this? Yeah. Lock. What? Just want something that is this a jump? Yeah. It'll make it much easier to browse around this way. So we have a little mystery here with a A4 that, oh, this one A2, that one matches. A2 is the number of parameters, I think. So that is unknown. So this is why I do like unknown parameters, maybe, you know, just get something in there. 77, do we have that? We do not. Do we have a 169? Yes, we do. That is number of art meshes. Then we have A2. 162 is the number of parameters. Then we have 62. That's number of parts. Again, yes. Then we have what looks, I'm going to guess this is a dimension. I don't know for sure. But I'm just going to go ahead and guess that that is possibly a dimension XY. But this is a complete guess. So we have two dimensions that kind of look like plausibly width and height, but I have no idea about that. They could just be counts of some of their sections. So I might be completely wrong because these all look like counts of things. So I'm not sure if dimensions make sense. Then we have another unknown. Now this one here is a very big number, which could be the number of vertices or something like that. If we go back here to the big section, it's like 34, 40. And we can do a little bit of math, right? Let's take this section, which has this number. Copy value. Do I have a calculator or something? No. Let's do a bit of math here. So take Python. Again, this is just wild guessing here. So we have that address. We have the previous address. So this section is pretty big, right? So this is the length of this section. Oh, what did I just do? Oh, right. The start and end keys are not mapped properly. I need to fix that. But this is the length of the section we have. And we have a number here that's pretty big, right? So is this number, for example, this number divided by 4? It is! So that is probably a number of 4-byte somethings. Hard to say which. And it's not vertices, because vertices would be XY parameters. So it's called big section. Non-big section words. Then we have a 152. Was that a thing we had? No, we don't. And then a 7D, 125. That's still not a thing. And we can line these up later with the section sizes, right? So some of these will be number of items in sections that we don't know about. I think I just copy and paste this a bunch of times. So let's just say model header. I don't know how many I have, but 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20, 21. And we can just say model header. And that was a 0. And I need a few more. 3 more-ish. All right, so that's our model header. And we can close these and make this a little bigger. So we have some interesting information here. Number of parts is 62. Get the console. Number of deformers is 241. Number of art meshes is 169. Number of params, 162. I have another number of parts. And the others are mostly just different numbers. So we will figure these out over time. But let's do a bit more recon. Okay, so the next section starts at 8C0, which I assume is where we were on the offsets. Yep, 8C0. So the next section has... This is interesting. It only has a few things. And they seem to be fairly big numbers. They are not file offsets because they are too big for that. You only have 5 of them. They are not exactly increasing. Oh, these are floating point numbers. Look, 2100. These are floating point numbers. So these could be float headers. Yeah, these are round floating point numbers. See, when interpreted as a floating point number, these are nice round numbers. So I don't know what they are, but they are possibly pixel numbers or physics settings or something like that. Well, physics doesn't make sense because we know this in the JSON. Possibly pixel numbers. So let's go ahead and write that down. Struct model. Let's call it just model floats, I guess. And I'm guessing these are possibly pixel numbers, but I do not know. So we can just have that. So because these are floating point numbers, they probably are pixel dimensions or something like that. When you see floating point numbers, it will typically be either a coordinate or a physics-related thing. And since we know physics is in a separate file, I'm guessing these are, possibly dimensions or possibly just things like the center of the model or scale or something like that. F32 is not a thing. Okay, is it float 32? Is it just float? It's just float, okay. So now we have the floats, and they are some 1,000-ish numbers. We have the system uses 32 or 64-bit floats. Yeah, usually it's 32-bit floats. You will not see 64-bit floats anywhere in graphics. Internal formats maybe, but not in graphics. Is this the... Oh gosh, it was. I wasn't looking at live chat, so let me fix that. Sorry about that. I keep forgetting that YouTube hides chat sometimes. Why not F64 in graphics? Because you don't need that precision for that precise numbers in graphics, and a lot of GPUs don't even have 64-bit floating point support. Like Apple GPUs don't, for example. You can do it in software, but it's pretty slow. So. Okay, so we have the next section. Now, looking down, we have a list of part names. And each part name has a fixed length. So, ideally we want some kind of data type that gives us a null terminated string, but I think we can just, because all the strings will just end in zeros, right? And I think we can literally just say this. part names, and it'll be how many bytes? 40 bytes each. And the number of part names would be mHeader.numParts at offsets 3. Make this a little bigger. This may not be happy about that. How do I do arrays of arrays? I don't actually know if you can do that. Data types, arrays. Unsized, loop sized. I think you probably need a, I probably need to like declare a type def. Yeah, so I can just say, using identifier, let's call it that, equals car 40. Is that a thing that I can do? That may not work. It doesn't. I guess maybe it doesn't let me do an array. Yeah, you can. Okay, you can use multi-dimensional arrays, but that's not necessarily what I want. Let's see. Data types. Strings, pointers, bit fields. There's a size string. Okay. No, it's prefix. That's not what I want. I mean, you could just have alternating strings at different start points, but I kind of want to just have a fixed size. So, I think I can just use standard array. I don't know if it's gonna work though, but that did something. Oh, it's the other way around, sorry. Size type. No, hold on. No, it's type size. Car. I guess that only works in nested type, so okay, so I can't do that. Okay, I use a struct, whatever. Yeah, that's gonna work. Part names, and then we just have the annoying thing is this has these struct identifier things in there. Can I call this inline? I think this is inline attribute I might be able to do. No. That's annoying. I was like, I want to just show them here. I mean, I don't have to, but it would be really nice to actually see, like, and also, is there a way of doing like an alternative string with the sides? Nah. About attributes. Can I make it a line? Can I do that? No. Oh, that works and breaks everything. Okay, good. No. Try again. There's a fixed size. Okay, that makes sense. Yes. Okay, so what I can do is using... This makes more sense. Hopefully this works. I can do using identifier equals... std string null string fixed size 40, and I need to import std string. This is just me messing around with this. That worked kind of, but it doesn't show them. Oh, okay. Yeah, it does show, sorry, it does show the value, yes. Whew, it works, okay. Yeah, that's what I want. Excellent, okay. So that's the magic I wanted. So this is saying that each part name or identifier is a null terminated string and then has a fixed size so that it will be padded out to that size. Which means you would get all the part names here very nicely. So let me put this into here. I want to have all the sorry, this is the wrong section. Is it 3? Is it 3? Hold on. I'm a little confused. Offset's 3. Did I lose an offset? 900. What's a 900? Oh, nothing. Okay, so we don't know what this one is. I'm just gonna leave a comment there because I have no idea what offset 2 is. So you have all the part names, and now let's keep going. So after the part names, we have looks like some list of integers. And how long is that list? So we can take this array, and it looks like it stops here, and there's another thing after that. So this array here has a size of how do I find that? F8, 248 bytes. And what is that divided by 4? 248 divided by 4 is 62. Do we have a 62 in the model header? I think we might. Yes, that is the number of parts. So there is a mapping between parts to something else. So we can write U32 part something index m header dot num parts at offsets 4. And that's wrong because offsets 4 is also 0. So then it's offsets 5. 5. I like this editor. This is pretty cute. It's not 5, it's 6. Okay. Try that. Wait, hold on. Is it 7? I'm so confused now. Or did I just not click on it? Oh, no, it is 5. Sorry. I have to click on it. There you go. So it's 5. And the next one is also a list of somethings. So this is where we get this struct of arrays thing. These are individual settings for the parts. And they are a struct of arrays. So each one is individual. We're going to see individual items about the parts. Now, the good thing about this is that means the file format is not as complicated as we might expect, because we have a lot of fields, but they are simple fields. They are just one number each. So the next one is also a number of parts. The next one is also just kind of looking at the zeros here, a number of parts. The next one is also a number of parts. And I am guessing that these unknown ones are also a number of parts. I'm just gonna give it a shot and see if the length matches. So we do that and look at part unc1. Does it match? Actually, no. It looks, and I'm just guessing here, like it's twice. So either it's the number of parts times 2, or it's something else. Let's just give it a guess here that it is a tuple of two 32-bit integers, because if it's, we are getting a lot of part-related things in sequence. Now, we don't know anything about this section, but just from the length, I can kind of infer that it's related to that. So if it is twice the length of what I expect, it's either a bunch of 64-bit numbers, which is unlikely, or more likely a bunch of pairs of 32-bit numbers, like, for example, offsets. And maybe they're all 0 because they just are. Let's call this U32X2. And if I play that again, yes, it fits just right. So again, I have no idea what this is, but one thing we can do later is just change these numbers and see what happens to the model. So it's good to at least have some idea of what these things might be. So it's part unknown 1, which seem to be possibly tuples of 32-bit integers. Then after that, after the identifiers, we have kind of just visually looks like another times 2. So let's just say this is offsets 4. And again, that, oh, does it line up? Actually, no, it doesn't. That one is just once. So that one is just U32. Yes, I think. So you have unknown 1, right length. Unknown 2 is the right length. Yes. And then we have something index. Let's call these unc1 0 and unc2 0. Then we have unc index. And one thing that's interesting is, are these indices, they're counting up-ish to about 61. Do we have 62 of anything? Well, that's the number of parts. So that just kind of looks like it's the part index, like part number, right? Because it's just counting up. And there is no there's no breaks. So let's just call this part index. It could be an index, it could be a it could be a Z order thing, it could be something like that. We don't know. What is this called? Part index unknown. Then we have a bunch of ones that looks like a flag, like a 1 or 0 flag. right? So again, we have park flag. It's called flag 1 at offset 6. And then we have another flag, possibly, at offset 7. And then we have another one at offset 8. And then something interesting happens. Then we have some indices that include -1, which means there is a negative. And these look like part numbers again. Now, what could map parts to other parts, including 0, including nothing? Well, I am guessing that this is a parent part index. And then, because we have a -1, this is a signed number. That means that the first part is a root part because the parent is -1. Now, I'm guessing this parent idea is just a guess, but it makes sense for parts in a model to be in some kind of tree, right? And so that means that the first parts here are not parented to anything, but then the next parts here are parented to part 6, which happens to be one of the root parts, and the next parts here are parented to 7, and so on and so forth. So this is describing a tree structure for the parts. And then again, we have a bunch of zeros, which we don't understand. I don't know how big that is. Let's just call it UNC20, and I don't know how many is per part for this one. So we have, looks like a bunch. So I'm just gonna arbitrarily declare some types here that might or might not be. Oh, I should save this. I definitely should save this. Might or might not be. Does this work? This works. The 6 here is a guess. It's too lazy to do the math. It's a little more. It might be 8. The type here is just arbitrary, right? Because I don't know. Yeah. Oh, that's too big. That's too big. It overflows into the next section. So again, I'm just guessing that this is possibly... Well, actually, no, wait. This should be the next thing. We have the number of deformers. The deformers. So this is probably not parts anymore. I'm going to leave that U32 there because it's useful. So the number of deformers we had is 241, which makes sense. So if we just say deformer... Let's use def, so it's a little shorter. UNC10. And offset's 10. Does that line up? Actually, no. So it looks like it's another x2. And now we are seeing something interesting here because we are seeing a pattern, right? We have the header, the floats, a bunch of things for parts, starting with this x2, which is quite interesting. And then, yep, just right. And then we have the names of the deformers. So def names. So now we have all the names of our deformers. And this is num deformers, not num parts. The scroll is a little weird. Right? It scrolls like too much. I think there's a bug there with the scroll amount. Arigatou. Okay. Have fun. Hello. Yeah, there's some kind of header that has like 8 bytes per item, and I don't know what it is. It could be a unique identifier. It could be space for something else. It could be a legacy thing. As we have no idea. But it's something. We can try changing it. One of the things we can do is fuzz the file, which means we can, if we start changing individual numbers and reloading the model in V2 Studio, that could be confusing. It could be difficult to, it could be tedious. So one thing you can do is bisect it, which means we could just fill a section with garbage, see if it does anything. If it does something, then you start simplifying it and seeing if you can make sense of what it does. And it probably will cause V2 Studio to crash. And, someone wants to figure out some exploitable bugs, then they can do that. So we have a list of deformers. Then we have what after that? That also looks like oh, this is interesting. Look at these numbers. These numbers, how high do they go? They go up to about 67, 77C, 124. What do we have 124 of? 125, this is +1. Well, MOC3, which we don't know what that is, but we know it's something. So those are mapping deformers to somethings. Which means this MOC3 is num something deformer. And then what we have is U32 def something index number deformers at offsets 12, which means there probably is going to be a section later that has some kind of, item mapped to deformers. So here's our def something index. Then we have a flag of some sort and another flag. And then we have interesting numbers. Oh, I think I know what those are. All right, let's copy some flags here. So we have offsets 13, 14, 15, and these are num deformers. You see how this all is starting to make sense? The thing about file formats is that humans designed them. Once you see what they're doing, once you see the design concept that went into this is structure of arrays. Once you make sense of that, it all kind of starts to fall into place. So this is def uncflag 1, def uncflag 2, and then we have def, and I bet this is part index. This is the part of deformer effects. I bet. Because these numbers, 27, they go up to about 2C. That's 39. How many parts did we, 44? How many parts did we say we have? 62. Okay, so maybe not quite right. Do they go higher? 2C, 2A? Maybe not. But it's something like that to be, it's not def part index, maybe. Because it's possible some parts are not deformed, of course. So 39. Do we have anything that was a 40 in the header? Not really. So my guess is this is the part index, but we will see. I don't know why sometimes it doesn't show it. Apparently you can book. Oh, it's a favorites. Excellent. I want that. So after that we have this is another tree structure, isn't it? This is another tree structure, and that one also looks like it has some kind of part association. No, these are deformer associations. So that's another parent of some sort, I think. Because those go up to 239 and we had 240. Yeah. You would expect that. So this is a tree of deformers, and this is a tree of parts. All right, after that is another flag, and these are very sparse. So these are actually flags that change. So that's interesting. Guessing there's about 2 of those, just eyeballing the lengths. Let's see if I'm right. Here's one. Yeah, and then zeros, and there's, oh no, it's only one of them. The second one is another index that goes up to A3, 163. That's not quite parameters, that's art meshes. Ah, so this is probably what art mesh each deformer acts on. I don't even know what the difference between an art mesh and a part is, by the way. As I said, I really don't understand Live2D cubism. Someone might be able to explain how this works to me. Okay, I'm gonna take a quick break and go quick bathroom break, and I'll be right back, and we'll keep going. But this is looking interesting. Okay, be right back. back. All right, so we are at art mesh index. So each deformer can affect different art mesh or something like that. Why does this keep disappearing? It makes sense because these go up to 163, which is the number of art meshes minus a bit. I'm guessing. So what else do we have? After that, we have, okay, another kind of index thing. So where did those go? Unc index. I think we have two of them. Just kind of winging it here. So this is one, and it does end there. Actually, is there zeros at the end there? Yeah, these are still, I think, parts. So you have some zeros at the end, which is a little... Wait, what? Hold on. Is that right? I'm confused. 964 bytes. No, hold on. This is starting at 0. Why is this ending? Oh, no, that's not right. Okay, so we have a different number here. We have, assuming that ends here, and this is a different number. This is 8310 minus how many bytes is this? This is 656 bytes. That's 164. That's parameters minus a bit, or parts, or art meshes. I mean, this might already be a art mesh list. $164. Did we have something that was 164? I think we did. Yeah, the Anquan parents, maybe. So that's something there. So that's not params, that's something. Let's call this we were looking at something deformer 2. So then that is num something former 2. And the length of that lines up perfectly. So there's something to index. And then, no, sorry, this is not something to, this is something to, it's a list, the length of something to. So this is something to, and the numbers here go up to 76 or so, 118, which is the number of, I don't know, actually. I had some comments here for the mappings of the indexes. Like these map to mheader dot num something deformer, and this one maps to we have 76, which is 118. Do we have anything that has 118 in the header? Or so, 119. It could be this 125 again. That would just about fit. So again, just at this point, I'm just guessing. But there's nothing larger than that. There's some repeats. And the biggest one is 118. So the count is at least 119. I don't see anything bigger than that. So we call this something to index, and this is mapping to num something deformer also. I think. So the size of this array is that num2 thing. And then this is mapping to that something 2 thing. As confusing as this is. So that there's another level of like mappings going on here. Yeah, I'm checking. So it's saying art mesh versus deform. I mean, I know what the deformers are. The parts contain art meshes. Okay, so it's like a higher level of nesting. A part contains deformers, which is apparent to art meshes. Okay, so it's actually part deformers, art meshes. Okay, that makes sense. And yeah, the texture data is in a PNG, so that's not interesting. Okay, so then we have another section that probably also has these, and these have big numbers. And they kind of look like multiples of 3, so I'm starting to think indexes of vertices. It is quite possible that all the vertices for the entire file are stuffed into one giant section, and then these are indexes into the vertex array, which makes perfect sense for rendering because you have a thing called a vertex buffer object in graphics programming. So it is possible that Live2D just uses one giant vertex buffer object and then just indexes into it. And 6, 9, I'm seeing, you know, XYZs in here. Which is interesting for a 2D format, but yeah. So let's see. So let's say the former. This is probably also something. This is a something to maybe vertex offset. And I'm assuming this is num something deformer 2 also. Yep, that lines up right. Then we have another number, and these are much smaller. These are going up to 27, which is possibly the number of parts. But it looks a little bit... This could be an index into something, or it could just be a setting. It could be bit fields, because I see lots of 9s, lots of 3s, lots of 1s. It could be a count. It could be a count of vertices. That would make sense, because we have start of 0. Oh, 0, 1, A. Okay, yes. So that's a count. 1, 9. Yes. That is the count. So that's the number of vertices, or something like that. Maybe vertex count. Now, one vertex doesn't make a lot of sense. So, that vertex idea might be completely wrong, because normally, you know, if you're deforming something, you need more than one vertex. And I would expect larger numbers anyway. So this might be completely wrong. So I'm just going to call it something offset. The interesting thing is that this is jumping a lot. Because I don't think they all add up to this much. Maybe they do. They might. Are there jumps here that are not explainable? 6B74. They might, yeah. So I don't know. We'll see. Click. Okay. So that's a count that we don't know a count of what. I know there's layer depths, but you wouldn't express those as a floating point coordinate in terms of graphics programming. So a z element in coordinates in floating point doesn't make a lot of sense. A z index as a separate thing does make sense. All right, so now we have another one with... Oh, these look like sizes. Because it looks like the count multiplied by 24. There's a 1, 9, and then we have 24, which is 36. And then 121, but that's not 9 though. That's interesting. I'm just gonna say something Mary vertex length. These are just, I'm just winging names now. But at least the count here makes sense. 331, 121. And there's a lot of repeats. It says 191133331, 191133331. So it looks like 9 and 3 both have a 79 here, which suggests that what's 3 times 24? That's 60, which is close to 79, but not quite. So yeah, it's related to these. It's possible that these numbers here are actually just type IDs or something like that. Does this line up with the sizes later? So we have 1911. Yeah, those are definitely lengths, especially if the 20-something, that is how that makes sense. Where's that? 27 at a bunch down there. Hard to say. I'm too lazy to look at that, but yeah, those look like counts, and then I don't know what this is. But they're somehow related to the counts or the types. This will be later. I think once I'm done with the top level arrays here, I'm gonna start writing this in Python, and then we'll be able to do more higher level analysis. But a little bit I can probably just do here. I don't know if I can do for loops. That'd be nice if I could do for loops. Can I like print in a for loop in this language? Expressions, functions. You can do for, okay. Okay, cool. So we can debug dump information later. And we might even be able to reformat the vertex structures here in a different format later. We'll see how much we can push this language before we switch to Python. Okay, so next up we have 5A, 5A. That looks like another. Oh, that's actually related to these numbers. I think that multiplies. So 5. So those are the counts. 25. 24 divided by 5 is No, that does not work. Sorry. That doesn't actually work. 79 divided by 10. No, that doesn't add up. This could be a type identifier. I'm just gonna say unctype at this point because I need to see these numbers next to each other to make sense of what's going on here, and I can't in this structure for arrays format. And then I have another one, 5A, 55AA. Then we have another one. This is this looks indexy. That does not look right. Ending there doesn't make sense. I think we have a different count now, finally. So now we might be talking about, we were doing the deformers, something too. The next thing there is possibly art meshes. So how many do we have? Kind of looks like it ends there. I'm not sure. The scrolling is kind of glitchy. 30. So we have a 134. 77. No, could be the number of parts. No, I can't. Because we're hitting art meshes really soon. So the next thing should be number of art meshes. But this does not look right for that. If we start here, 1F, 1F, 10, 20. It kind of looks like this ends here, and then we have something else. What is this count? So we have 134. 77. That's strange. It might not end there though. Well, we can look at the next section, of course. We can see what the size is of this section. If we say 26, I'm too lazy to. That's 26. Okay, it does start there. So it is where I thought, which means this is size 77. Is there 77 in the header? Yes, there is. That is Unc 2. Okay. So something deformer 3. Because that seems to be related to deformers. So we have something 3, unknown index at 26. Sorry, no, this one. 25 and 26. So let's see if those indices make sense. And then this is something deformer 3. And that makes sense. And then the numbers here go to 7C, which is 124. And what do we have 124 of again? 125? That's the something deformer. So again, this is a map to num something deformer. This is repeating all the time. I really wonder what that is a list of. The second one though is the second one is again some kind of this is an offset. This is an offset into something. Nine, 12, 15, 20. It's got unknown offset. And then we have... That looks size. That's definitely a count. 993. So this adds 9. Then that's 9. It's 18, which is 1, 2, and and that's 3. Yeah, so this is an count. And this one, dare I say, looks more like a vertex count. Because we have 9 3s, 2s. No, maybe not. There's a 1, 2. Okay, I don't know what it is. Unc offsets, unc counts. And then we have... a very strange array of, what I can only describe as possibly floats that end up at -0 for some reason, because 80000 is either a bit field or just a -0 float. Like, this is an array of 0 floats, and some of them ended up as -0 because technical reasons. I'm gonna say float just to be... Yeah, it does end there. And then we have a bunch of somethings. 29. Whoops. So how many of those sections do we have until we get to the art mesh names? This might be art meshes again, because remember we have this identifier thing at the top? So let's go, where are the art mesh names? The names, because we probably have this pattern again, right? So if we put this at 30, and this at 29, Artem. Not quite. Okay. The baby time? Okay, I think I need to take a quick break. Right back. I'm temporarily back. Let me tell you a story what's going on, because I just did something. So Cyan and I are trying to raise fish. We have some guppies, and they have babies, and the babies have been dying, and we've been trying everything to save them, and we have a separate tank now to... I think I figured out something about the water quality that was bad. Anyway, it's a long story. I have a little fish tank separate for the babies now, and for some reason the water quality keeps becoming terrible, and I don't know why, and I've been trying to remove root causes, and it's been getting bad again while the stream was running, and so I'm rushing to do another water change and trying to figure out. I want them to survive. So yeah, I've been fighting with that. The stream is flicky? How do you mean flicky? So yeah, I'm transferring some water right now. I'll be back again upstairs in a few minutes, because I'm using a tiny little hose. I'm pulling water from the big tank this time, because I took almost all the water out of the tiny tank, just to get it fresh. Because our big tank is great, has great water quality, and then the tiny tank just has been crashing recently, and my last guess is one of the plants we had in it was decaying too much, so I just took it out, and I'm just kind of hoping that once I finish this water transfer, it'll stop being so bad. But yeah, aquariums are hard, and I've been learning a lot. So I have to go back upstairs to check on the water, because I have a little tiny tube running between the aquariums now. That's the story. So yes, our babies yeah, need hidey places. I know. So the thing is, if we leave them in the big tank, they don't survive, even with some hidey places. We've been trying to raise them in a separate tank, also because the water issue, we weren't sure if that could be a parasite or something that was causing them trouble. And last guess I had was that the water hardness wasn't high enough, because the water is pretty soft in Tokyo. So I've been adding stuff for that, and I think I have the water parameter stuff under control, but it's been a very long thing. It's been like the past month and something, been trying to figure all this out. But yeah, I don't know why the nitrates keep climbing really high on the baby tank, even when I don't put food in there, and it's like it's like something is decaying, because it doesn't make sense that a bunch of babies would produce that much waste to cause the nitrates to climb. If you don't know about fish tanks, there's a water cycle, which is like the way waste products are converted into less harmful compounds in an aquarium, and you need bacteria for that. And so you have ammonia, which becomes nitrites, which becomes nitrates, and nitrates are okay in reasonable doses. But I'm having the nitrates climb, which means something is producing ammonia, and then our bacteria can keep up converting them to nitrates. But that doesn't make a lot of sense, because like that happens when you overfeed, but I didn't even feed them since this morning, so what's going on? And I've been trying to eliminate causes and kind of leaving the tank bare in the process. The filter does not filter ammonium nitrates. The filter usually houses bacteria that do that. But actually we have a bunch of biofilm on, like, they seem to like to stick on the little tank. We have a sponge filter, but the bacteria seem to like to stick to like rubber things like hoses and the suction things on the sides and the heaters. It's interesting. Like, you get, slimy bacteria just actually good for the fish tank when they leave that. But yeah, one thing I might do is just get a bigger filter, put it on the back, because if you have a filter that has a place for bacteria inside, the thing is the bacteria get a water flow through them so they can work more efficiently. But again, the problem is I don't understand where the source of all this, waste product is coming from, because I literally don't have anything in the tank. Like, I'm not even feeding them at this point. So, yeah, I'll be right back and check on the water transfer. Okay, I think it's a couple minutes. Okay, the person, do you want to find the chat? Scroll back to the beginning of the stream and watch that part, or read the FAQ, because I answered all of your questions. And for what it's worth, I've been talking about this on Twitter, and I have not had a single rigger opposed to what I'm saying and my arguments. Everyone kind of, you know, contradicting me, and the discourse, capital D, was not a rigger. So I think, you know, if riggers have concerns about what's going on, we can have a debate, but I don't think you need to worry about that if you're not a rigger. So anyway. So I need to go back upstairs to check on that, but let me get these IDs hopefully sorted. That's not right. Yeah, that's not right. And it's not num deform, it's num art meshes. Still not right. Still not right. 33. 24 maybe? No, 33. There we go. That starts there. So I'm guessing this one. Yes, that we have the weird double thing at the beginning, which means we are still missing 30, 31, and 32 in between. So we have some zeros. And then possibly a bunch of those zeros. So let's see if the sizes line up. 1, 2, 3, 30, 31. Uh, 6, 7, 33. No, that does not line up. That is bigger. So I'm gonna just use this type. That still does not line up. Looks like that section has 29. About double that. So let's do it times 4. Five? No, it cannot be 5. So this is still quite unknown. It could be a different count. It could be something that's not the num something to form a 3, but rather could it be num art meshes? Oh, actually, yeah, that makes sense. It's like you have a bunch of these. I think. That lines up with the lengths, I think. Yes, that aligns correctly with the next section. So these are art mesh parameters, but they're all zeros. We don't know what they are. And then we have the names. Perfect. Okay. All right, I'm gonna go upstairs and check on the tank. Be right back. Okay, I'm back. Sorry about that. I think I got the fish water in the baby water into not imminently dangerous levels. Still a little questionable, but we'll see. Okay. Would this project still have happened if MOC3 was obfuscated? Probably yes. There are ways of figuring out most obfuscation. If it were like outright encrypted with a serious encryption algorithm and a fixed key or something, then honestly at that point I would just ask someone in a country where reverse engineering for interoperability is legal to just decompile the software and get the key out. Okay. So, alright, I mean, they look okay. They're happy. They're not dying or anything. I give them a tiny bit of food just to make sure they don't starve without destroying the water quality. I'm just kind of hoping that what was left there was like remnants of whatever happened with the plant before, because if the nitrates keep blowing up in this tiny little tank with like nothing in it, I don't know what else there is to change. I mean, I could just move them to the big temp, give them places to hide, and hope the adults don't eat them, but that's yeah, anyway. So art meshes, we have a list right after that, and this is going to be a list of some things. So U32 art unknown 5 index. Let's see what this is an index of. This is 34. Click. And it does line up. So this one has an index up to 1D. So what do we have 1E of? We have 1E of anything. That's a pretty small number, actually. That's 30. And we have a 29 here. 1D. But no 30. Normally a count is always last index plus 1, so that does not quite line up. It could be that 0 is special, and then there's an offset there. So we're gonna make a note that this could be an index into Onc 20, possibly. But possibly plus 1, because there's that off by 1 problem we have. All right, after that, we have another, okay, this is an index into something, and there's gonna be a length after. Yes, there is. Okay, so we have an index and a length, offset count, let's call this onc index, offset count, 35, 36, click, click, click. And yeah, let's go to F2. No, we don't. No, that's bigger. That's not. Oh, sorry. Num art meshes. Num art meshes. Yeah. So there's an unknown offset. They go up to 1FF, which is an interesting number. 511. Do we have anything that has a 511 in the header? 512. Not really. And this is the Onc 1, but it's not. It doesn't quite add up. So we'll have to leave that as unknown. And the counts just are, yeah, very generic. After that, looks like we have some possible flags. I think at least 2 of them. Yep, there's 1, there's 2, and then there's another index. This index looks like a possible tree because we have the -1s. And they go up to... They go up to about 32, which is 50. What do we have 50 of? Parts? It could be a part. Parent could be a part. Yeah, they go up to 3D, 61. Yeah. Okay, this is the part. And the ones that aren't assigned to parts are interesting because that means there are art meshes that don't have a part assigned. So this is S32. I don't know if that makes sense or not, but... taking a BTS pin, turning it into a panel, talking to a model. Yeah, that is exactly what I'm trying to do here, is being able to merge models and things into models. So that would be essentially one of the primary use cases, except not just the pin, but you could have a new outfit or something like that. All right, another set of indices, but these go up to 5. No, these go up to 240. I think I saw that somewhere. That's the deformer count. So that looks like... Really? Do art meshes only have 1 deformer? I'm not sure that makes sense. These go to 234. Yeah, that's a deformer index, but I thought the idea was you could deform a part with more than 1 deformer. Because otherwise, how are you going to do different motions? I don't understand how this works. So, but deformers have parents, so maybe that makes sense. Maybe you chain deformers, and then the part has like the last deformer. Maybe. Because then the deformers also... Oh, this is interesting. We have a hypothetical art mesh index in deformers, and then we have a hypothetical deformer index in art meshes. So is there 1-to-1? No, that doesn't make sense. But almost. If deformers don't always have an... Oh, if they're chained, maybe they all chain up and you get... Okay. Or maybe I'm just, interpreting this entirely wrong. So we can show that. Let's actually print a log here. Let's see if this makes sense. So we print... If we print the first deformer index of the first art mesh index, that's 29. No, that does not line up. No, that does not even remotely line up. So this does not make sense. Do we have more than 241? No. Okay, so one of these is wrong. So we have the art mesh deformer index, and the length of that is right. And these go to 238. No. 240. Yeah. Oh, wait, hold on. Yeah, F0, 240. Nothing bigger than that. So that pretty much has to be a... Correct. So what about the other way around? The former art mesh index. These go up to 163. Yeah, it still kind of lines up. Do we have a number in the header that is similar to 164? Oh yeah, we have several of these. Oh, okay. Okay, I think this is probably not an art mesh index. 169. What is the biggest one we have? $163. It could be a parameter, and then we're like off by something. Yeah, our mesh number makes sense. You have a different thing though. There's another in the header here. We have a 164, and we don't know what that is. And oh, it's num something deformer. Okay, so that actually, it's probably an index into that then. Whoa, that's weird. Okay, the UI scaling is really confusing. So that makes sense because the max number in that one for the deformers. Actually, you know what? I can write a little script for this. Let's make a function. Is there a max, or they might even have one already? Limits? No. Math is max, but that's for is it an array max? No. I'd probably just write something for that. All right, let's write a little function for this. You have this fancy auto stuff. Can use ref auto array. How do I get auto max equals 0, and then like if r I is max, so it's RAI, is this gonna work? Actually, I can just do this. That'll probably get the auto to work. So if I do print, a max of that, 163. And the M header, yeah, so that's not art mesh. That is the something deformer 2. And I can't fit this. Let's make space. Yeah, num something deformer 2. And that makes sense because it is the last array in deformers, and then we have the something 2 array, whatever that is. So that now solves that confusion. All right, so back to the list. Immediately see the field within this. Yeah, I think I'm gonna try 2 things. I'm gonna see if I can actually declare structures of like deformers with all the members in line and have them read from the offset. I want to see if that works. If it works, we use that. If it doesn't work, I'll do a print function that can print everything in line for a single deformer, and then we can like print them all. Make sure this is saved. All right, so deformer index. And that's interesting because it means our meshes only have a single deformer, though they could have a chain, I guess, of them. Then we have a flag. Looks like. Click. Oh, interesting. It's not a flag. It's maybe it's a type. Maybe it's a type. Maybe it's an index or something like that. So let's put a 0, 1, 2 document there. Then we have another. Ooh. That's a byte array. Yeah, that lines up. 4, 6, 6, 4. 4 and 6. Oh, I know what this is. That's the texture index. Because this model has 3 textures. Texture atlas index. And that's why they're mostly in order, because the last ones would have been added last, so they go into the last atlas. So this is interesting, the 4644. And then we have another list of indices. Click. Oh, that does not line up. Those are not art mesh counts. So remember, art meshes are going to have vertices. So now we're really starting to talk about vertex indexes and stuff like that somewhere. Oh, these are big numbers. Okay, so that looks like a possibly vertex offset and vertex count. Oh, sorry, on U32, I'm dumb. Yeah, that lines up. Okay. So we have another max. The max here is, this is probably vertex count. That makes sense. This is probably vertex count. And then we would have vertex offset. And remember, this is a mesh, so we need like triangles, and so this could be vertex count, or it could be like triangle count, primitive count. And I think I'm just seeing here that this is vertex count and primitive count. Yeah. So this is probably prim count. And then we have prim offset. Or as we call, actually starting index. As we call it in graphics, this would be an index buffer. And then possibly starting vertex. Now that doesn't make a lot of sense. It would not be a number like that. Well, this starts at 4A, 3F, and this is 94, which looks like twice that. Yes, so that means that these are, if it's XY, because these are texture coordinates, this would be texture coordinate count and texture coordinate count and texture coordinate start. Texie count and texie off, because those are XY. So that makes sense. And then what about the primitives? 126, 23A, those are big numbers. Is 126 divided by 94 a number that makes sense? 126. Oh, yeah, almost. So about 94 plus 3F. Do those line up? $112. I think so. Yes, that lines up. So what about these? 126, 23A. Roughly, but not quite. So this is also an offset, but a little different. So what we are looking for is a list of triangles at some point. There's going to be a list of primitives. And this could be a starting index. If the index is a 16 bit index buffer, which, well, we might be able to just guess by looking at the file. So let's see if we see something that looks like a 16 bit index buffer. That does not look like it. Those are floats. Those are floats. That's like the big vertex buffer that I mentioned. Hello! Thank you so much. 3 months. Hello, Beauty Fantasy. It's been a while. Hello, Marcin. It's been a while. Yeah, this is really big. Okay. Look, there's 126. Okay, these are the counts. This is another offset, and then this is a different count. For some reason, it's the other way around. So these are the counts. And then these are the offsets. And those could be the those could be the indices. Because for a standard grid, if you have a grid of if you have a 2D mesh, then roughly speaking, as a grid, your number of quads is the same as the number of vertices, minus a little bit. And so what we had there was, for example, we have 4A, and then 126. If we have 4A vertices, and we have 126 somethings, that's about 4, which makes sense. 4 vertices per quad. So it's likely they're using quads and not triangles. So this is probably quad offset, quad count, and then these would go into an index buffer. Actually, it'd be sorry. This is the this is the vertex offset and vertex count if they're quads. So not vertex offset. It would be like index offset and index count, probably, because And then we have another array we don't know about. These are fairly small. So U32. And they go up to 17. What do we have 17 of? That is 23. Possibly Unk 8. But there's also an off by 1 problem now. So it could be this +1 business again, where 0 is special, and then they start indexing at 1. That is not too impossible. Okay, then we have some flags. Unk flag 3, I think. Yeah. Click. And then we have some zeros, and then params. This could be the X2 business again with the identifier. So let's do that again. Param Unk 0. Let's see if my guess is right. Params. Click. I think it's right, and the length of this is just right. Yes. So we have the parameter names. And what do we have after that? All right. Okay, we have some floats. That could be something like default value or minimum value or something like that. So let's see what we have. How do I know these are floats? Because of this first byte here, when this is 3F41, or they have this kind of pattern, these are almost always floats. And you can see in this case that the float value is 1. For these, it is 30. So yeah, pretty obvious. You get used to recognizing these patterns when you do this long enough. So value 1 has like 1, 1, 1, 30, 1, 1, 1, 30, 10, 30, 45. Oh, the 30s and 45s are angles, possibly. Then the second one is 0, 0 minus 30. Oh, okay. So that's max, min. This is starting to sound like max, min. Max, min. And then this could possibly be default. Parent default. Lots of zeros, a few ones. Yep. All right, that's after that. After that, we have some unknowns. You scroll back up here. Those are all zeros. And then I bet this is like a type or something like that. It'll look like 3. Yeah, they're all 3. I don't know what that is. The next one, though, has some interesting numbering. So that's an index. Clickety click. So that one has -1s, so it is signed. And the max we have is 7F, 127. What did we have 127 of? Nothing. Okay. Anything in the header? Ah, UNC4. Okay, that looks like... And then we have another flag of 1s and 0s. Clickety click. And then that looks like floats. Clickety click. So we have a lot of 500s. I wonder what that is. 500s. And then 0 and 1. That's very interesting. I have no idea what that is. Oh, actually, wait, no, that structure is wrong. This is not aligned because how big is that? This could be a different number. Oh, it does start and end there, actually. Does it? Hold on. No, I think we're wrong. No, this is not the number of parameters. This is a different count. We have, actually, just a few things here. We only have, F70. How big is this? Yeah, the scroll is a little broken here. We have 248 divided by 4. 62. I bet that's a number of something. Parts! That's a number of parts. This is a part something. No idea why we are back to parts now, but I guess we are. Click. So this one's 500s. This one is 1s. And then we have some more. Oh, no, this one is different. This length is actually longer. How much longer? Let's put something on float 60. Actually, you know what I'm going to do? I'm just going to cheat a little here. I'm going to put a bunch of markers at the offsets. And that way I can just keep moving that and replacing it. Just do it like that. So what we have is a bigger thing here. How big is this? A lot more actually. 15D00 minus and actually how much bigger is can't tell. Minus 13F80. I would like to make my home and end keys work. How do I do that? General. I did this once in a different computer. Keyboard. Home. Modifier none. Action syntax. I think you do backslash. Whoa. Great. Backslash B. I think is how you do this. Backslash E. I think that fixes that. No, it doesn't. How does that work? Terminal, home, and... I don't think it was that complicated a string. It's 1 and 5. Okay, 001, 005. Or maybe it should be bash. It's Control A. Okay. You have to type Control A, right? I don't know if that works with Python, but let's find out. It does work. Okay, good. That was really annoying me. 13F80. 15D00. Okay. So we have 1D80 things, and they are floats. So divide by 4. 760. What do we have 760 of? That's a big number. 1888. Oh, well, that looks close to maybe width, which is not a width at this point. Okay, I'll just make this up. So Unc. Count 1, count 2. So those are floats. Oh, this is interesting. Okay, so remember we have parts here. So we have num parts and then we have num parts too. So there's like an extension to parts. So I'm going to assume these are num parts too. Because it's all in order, right? Params, parts 2. So and then count 1, count 2. Oh, did I just crash? I hope I saved. I think it just died. Oh no. Is this gonna be a series of live streams? Oh yeah, this is gonna be a pretty big series. That's not good. I think it just died. File has been modified by external source. Oh, that's because of the networking stuff. Is my NAS dying? That would explain if it's doing that, but I hope it's not dying. No, it's fine. I think Imhex just died. I hope it's saved. I'm gonna take a screenshot of this last part. How do I do that? Command Shift 4? No, how does that work? Yeah, take a screenshot of that just so I have something. Ah, there's a restore. Cool. Thank you so much for that. All right, we didn't lose anything. Nice. So, there's the floats, and yeah, that's about as much sense as I can make of that. Mostly ones. Bunch of zeros. Don't really know what these indexes are for. There could be alignment here, but this starts at D00, so C00 is about as much of a count as I would expect there to line up, so it doesn't do that. Okay, D00 is interesting. So these are indices into something. And it does line up. And that could be the offsets into the float data, into the vertex data. Offsets, okay. So after that, we have a small, not too big list of floats. Yeah, scroll. Can I change the scroll amount? It's really annoying me. Interface. Can I change the amount here? No, I can't. I guess it's kind of buggy about the amount it scrolls and it's getting annoying. I wonder if I can change that somewhere. Hold on. Ah, this is scrolling speed setting. Okay, so if I make that slower... No, that's still going by big jumps. It's going a full page. I like it when the scroll, like... is a little less than one page. I guess I can't change that though. Is there anything for that? Yeah, maybe there isn't. Okay, so I guess at least it's one page. So, no, see, here I scroll down and it goes from 63 to 67. So it doesn't work very well. Not deep wiki. Project cache backup. Yeah, file, save, project. Oh, it goes to whatever. I guess there's no option for that. There's no like synchronized editor scroll position. That's what that does. Oh, you can change the accent color. Let's make it pink. That's nice. Nah, I think I just deal with it. Okay. Yeah, I'm using a regular mouse, so how does it behave with the trackpad? Actually, with the trackpad, you get like single lines, which is nice. It does have smooth scrolling, but I'm using a mouse, and it does not work very well with the jumps on that. Maybe I should use a magic mouse. Is there a way of changing that? macOS mouse scroll step. If I make the scrolling speed slow here, does that affect this view? That seems to be... No. It doesn't do anything. I don't know if that's a thing you can do, so... I think it's not a thing. I guess you have to use like an extension and stuff. Nah. Search for scroll here. Problems with scrolling remain. Nah, I'll just deal with it. I don't think you can do much about this. Unless there's a magic setting somewhere. I bet it's related to the scaling where it doesn't quite calculate the scroll right when you're using scaling, but I don't know what to do about that. So, I'll survive. So, UNC offsets, they get pretty big. To see something. And the only thing that these offsets make sense as is offsets into this huge section, X71. And they look like C3BF0. (24.30). Yeah, those only make sense as offsets into this section because it's the only one big enough to hold anything like that, and they're all aligned. So I don't think it's even unless there's more, because we have more. I haven't actually added to enough sections though. So we have more. I should just make a for loop, shouldn't I? I'll probably do this with a for loop, but... yeah, we still have more. Oh, 34 to 38. See... no, that still doesn't line up. Now, I was changing the scrolling speed and it doesn't actually work. How many more offsets do we have? We have 151 offsets. I guess at this point I can just do it by hand. So we're looking for anything that has a length of around C something. Nothing does. So those have to be either indexes into the vertex array, which I'm guessing is here. And they do have blocks here. So I think that's a big vertex buffer object and they're blocks, yeah. So those have to be vertex offsets. And this X71 is a giant VBO. So we're just going to do that right here. And we don't have the length of the VBO, though the header might have that. Yeah, non-big section word. So, just got a video size. Wow, the scroll is really weird now. Okay. Wait, what just happened? Oh, it broke. Okay. Index out of bounds. Oh, wait, sorry, I'm dumb. Yeah, so there's VBO, 3410 BF. Yep, exactly right. So these UNC offsets is VBO, UNC1 VBO offset. Has to be. I'm gonna comment these out so they don't pollute my view too much for now, since we don't need them until later. So UNC1 VBO offset gives you an offset into that vertex buffer object, and then like 0, 50, right? So if we go to VBO, I have 0, and then 50 times something. Yeah, 340. So if I do 50 times 4, it's 140. So 340 would be, yeah, exactly. So that's not, it's not VBO offset, it's VBO index. So this is the index into the VBO where you start for whatever UNC1 is, and I don't know what UNC1 is. This is all very graphics coded. This is all very clearly written by someone that is implementing stuff that is going to be partially done on the GPU, partially done on the CPU, all that stuff. It's actually kind of clever. Okay. Then we have something much smaller. These are just floats. How many of them do we have? That's not working. Yeah, the UI is a little bit glitchy on this. 5BC. That's 16F, which is 367. 367 floats. What do we have 367 of? Nothing? It's not even a, it's not even, I mean, there could be more, because there could be just zeros after that. But not that many. I get 367, 384. And since it's not a multiple of 2, it could be a multiple of 3. $128. So I think these are coordinates in tuples of 3. And then we have this UNC4. That, I could buy that. I could buy that. I could believe that. Wait, we have 385. It could be this UNC2, sorry. That makes more sense. 385. I think. Sorry. The scroll tricked me again. Ah, but no, that's overflowing actually. Wait, hold on. No, this is empty. I'm dumb. That is empty. Sorry. This. Oh no, there's no 61. I'm done. Okay. So, yes, that does add up. So that's num-2 floats. And I guess it ends in zeros, which is a little bit questionable, but it does kind of make sense. At least in the order in which they are being added, and also because this is aligned to 40. If it ended here, it would begin here. So it does make sense. We have some zeros at the end. And so this is float. And float, and yeah, a lot of ones, and then some zeros at the end for some unknown reason. All right. Next up, we have some zeros apparently on this one. We? Yeah, because there's ones and zeros. Sure. No, wait, where are we? On 2 floats, sorry. Okay, next part. Next part, we have something interesting. This is very random looking. What could this be? These could be floats. They sound like possibly floats. Yes, these are floats because I can see the pattern in this byte, 4C4. So these are floats, and how many of them do we have? Possibly the same as before. Let's see if that works. Yeah, that works. So this is another list of floats, and these are actually interesting now. That kind of smells like an X position or something like that. But I don't know. They look very pixel position to me. But it's hard to say. And we have that number of them. And we have those weird zeros at the end, which is strange. Okay, looks like we have another set of floats. And those are also those are very different. Those are not that different, but a little bit different. So now we're starting to talk about very likely coordinates or something like that. And I would like to know what they map to, because it says num-1 and num-2. But we don't have any mappings for those. And if we look at num-1 and num-2 in here, 1874, 385. They don't really add up to anything. So I mean, and it's not even multiple of 2. It's not multiple of 3. It's a multiple of 5. And then we get 77. But is there a 77? No. Yes. Yes. It's num something deformer times 5. That could be interesting. So let's make a note of that here. Because that makes sense, that we have sections that are like mapped. Sorry, this one, 385. And then we have 1874. That is not 77. It could be 2. It's not 9, so it's not a 16 array. Is it 12? No. What about 164? No, you get 11 from that. So that one is still an unknown. But those are VBO indexes, so they should map to something like Artemeshes. Like Artemesh VBO start or something like that, which makes me think 169. I almost adds up, but not quite. It's not a multiple number of parameters. It's not a multiple number of deformers. Not a multiple number of parts, so we don't know what that is. It's divisible by 2. It's not divisible by 4. What does its factor as? It's not 5. Nah, I think it's just 2. So it's like a list of pairs, which leaves us with 937. And then 937 isn't really a number I see anywhere else. So, yeah, we don't know what that is. It could be multiple things added up, though. Yeah, I don't know. All right. So, moving on. X64 is another array that looks about the same, and this is also floats. We have more of these. I'm just guessing here. Yeah, these all add up. So these are all arrays of floats. And definitely floats there. That looks like a scale, quite likely. Is it 0.005? Not sure though. And does it keep going? I think so. So Octu is something interesting. This is an interesting number, and it was what did we say that was a multiple of Octu? It's the something deformer 2 times 5. So we're getting somewhere here. Yep, we're still doing arrays of floats, I think. These are zeros, but yeah, and then we have more. All the sizes are lining up here, so. X68 is more the same. I think all of these are more the same. And then we have the VBO, so this is getting interesting. Okay, now it's different. These are not the same. 7 is good. 8 is not. 8 is a different count. This has to end at F80. So you're looking for 1 AF80 minus 1 A640. We're looking for about 592. Did we have a thing? Yes, 586. That's Ank 1. Okay. So let's rename that. And what is that? 587. It's not a multiple of that. It's a multiple of 9, no. 11, no. 13, no. No, that's its own thing. So float 8 is Ank 3, and then I'm guessing all these are Ank 3, just kind of going by that. Yep, that adds up, and that adds up. So we have 3 floats here for Ank 3. Lots of 500s. 0, 1, 0. Oh, that's interesting. 0, 1, 0, 1. And then some 1s. Lots of 500s. And some small numbers. Oh, no, these are not floats. The number is right, but not the type. These are indices into the VBO. So now we're getting somewhere. You can see how that 08 starts. I'm so confident I'm just saying that that's what it is. The 08 VBO index starts at the end or not, actually. C. Did we skip 8? No, we have 8. Okay. Famous last words. 8 AC. This starts, last offset we have a C3BF0, and then we have a 8AF60, which is interesting. But maybe they are interleaved. That would make sense. So A08FOC, maybe the counts of the VBO here are interleaved, like these blocks. So once we figure out what the lengths of these VBO things are, it will probably not overlap with the other one because they do end at around the same place. So then we have the VBO. And then we can keep going. So we're getting somewhere here. Let's get to 90. All right, gonna take another quick break. Be right back. All right, I'm back. Let me fix my chair a little bit. Make sure I have good posture. All right. So more VBO offsets. And then after the VBO, we have some small numbers. What's the length of this again? $340 minus C0. That's 160 and it's a little less than that. So how many do we have? $152. I think I saw that number somewhere. Yes, that's UNC 2. Okay. So this is all kind of in order, right? So these are all array sizes. Num UNC 3. Just gonna call this num VBO floats. Oh, sorry, it should be 4. Click. Yep, lines up just right. And then we have another set of that many-ish. Actually, not sure. Might be a little different. No, that's not right. It's a little less. So probably another one after that. UNC 4. Oh, that's the num something in the former. Then we should rename that to something else. Yeah, that's right. So let's just call that UNC 4 and rename them. So UNC 5 is the one we were calling something deformer. Ah, sorry. This is UNC 5 index. And we have interesting references to this array. And these are all the same size, 3, 5, 7, 9, B. There's a bunch of things here, and they're all the same counts until 76. So the first one is an index. The second one is a count, quite possibly. Yes, the second one is a count. The third one is a different kind of index. Let's call this offset. Actually, start index, count. And then looks like you have some 3s and things in there. Yeah, so then there's another index and another count. So this goes up to 97. Let's document those numbers. 151. Where have we seen that before? Unc 4. Okay, so this maps to Unc 4. And then the second one Eric having oh, that's not right. That's not Unc 5. It's a little bit more than Unc 5, which is Unc 6. And those increase up to 1 FB, which is 507. I don't have a good number for that, but it could be an index into Unc 7 times 2. Or I'm just scrolling wrong. Hold on. 507. No, that one doesn't add up. Unless I messed up. Nah, 1 FB. Don't know what that is. And it's 1 FB plus 3. So that's 510. Yeah, that index does not line up with any of these counts. Okay, then we have some floats. And that's B40 minus C00. Just 48 or a few less than that. We have we don't have that. 48. Can I make sense of... No, not 48. Oh no, 2000. Sorry. 1072. Ah, there we go. Sunk 7. I think. Oh, wait. 125? 250? 500? This is almost 510. Not quite. 128. It could be Unk 6. Okay, where are we? Because we're kind of going in order. We have the floats, then we have Unk 6 start index. So we should be doing Unk 7 now, which makes sense. 1062. And those look kind of like parameter values, actually. Oh yeah, those are like angles and things like that. Interesting. So at some point, we're gonna have to sort of make a tree of what references what, because it's getting complicated. So that's max 510, whatever that is. It could be Unk 6 times something. But that would be... that doesn't... An index into itself? No, that doesn't make sense. And they're not aligned to anything, so that doesn't make sense. Okay, so the next one is that. And then after that, we have more floats. Possibly just Unk 8 for this one. Let's just wing it. Click. Yeah, that is the right amount. So these are interesting, more numbers. We really need to figure out what points to what. At some point, this is going to come together. There might be, offsets at the end that tie everything together here. X79. That's a big one, actually. Oh, this is the index buffer. I know what this is. This is an index buffer. This is a 16-bit index buffer. I was looking for this. There has to be an index buffer that specifies the starting vertex or primitive or something. And this is definitely something like that. Or the vertex number for each primitive. I bet these are quads. Because 1C4, 5D, 1C5, 6, 1D, 5, 1B, 1B, 1A, B, 1C, 1D, 1E. It kind of sounds like different, like 1C, 1D, these two quads share 2 vertices, right? That makes sense. Actually, no, they share 3. Is that possible? No, that does not make sense. Gonna be the triplets, C4, 5, D, 1C5, that makes sense. 6, 1D, 5, 1B, 1D, A, 1B, 1C, 1D. Well, we'll find out. Something will be an index into this, so. And we had some kind of references to things that I might have missed here, so. There's Unc 8 plus 1. What was Unc 8? I renamed these things. This might be Unc 8. Art M Unc 3. Oh, that makes sense. Art M Unc 3. That was going up to... No, that does not make sense. M header Unc 8. Ah, yes, that's a new one. Okay, not Unc 9. So let's call this Unc 9. I'm my keyboard. Ah. And this one I messed up by renaming things. Forgot what that was. Because I called it, okay, it's not Monk 4, yes. I think. It's, hope I did not mess this up. Yeah, so then we have an array of most likely start indices into something. Not sure. It's small. So there is a 20 here that got incremented to 1. I need to fix these names. I'm gonna have to verify these later anyway. So, okay, Unc 9. And offset's 80. Yep, that looks right. And these numbers are kind of just incrementing up to 108, which is interesting. Wonder what that is. All right, after that, we have some very small arrays. Like some of them are just one element. What do we have in the header? We have num.unc10, and that looks like it's used for a bunch. So x81. Yeah, these are all single numbers. And we have 1, 2, up to x. X86. Until x85, actually. Wonder what that is. Okay, then we have x86. That is a larger array. Could be num.unc11. Let's see if we guess that right. Yep, that's right. And quite possibly more than one. I think I see... Yeah, I see a bunch of things with the same pattern. So let's do 5. That one doesn't line up, so it's C. And then after C, we have a... Which, by the way, these are... Okay, that's... A is something zeros. B is an index into something. And the max here is... around 8. Which is 168, and I think that's one of the links we have. Yeah, that's a self-index. Is it? It could just be an order, but yeah, it does kind of look like an order. Let's go to self-index. C is all -1, so let's just call this an S32, assuming. Could be a parent. And then D is all zeros, and we don't know what that is. But we have mesh, T-mesh. Oh, hold on. Okay, so there's more things here. Glue. We have a glue array. And that quite possibly has the, hold on. So I missed those identifiers. We have 35 glue entries. Well, now we know what this one is. Num14 is num glue. Oh, and 12 also. So let non-glue 2. So you might have the same story with the names and the 0. Glue names. $91, $92. Oh, and I messed up that. I didn't update these. Ah, that is not right. I messed this up. What just happened? Oh no, so this is glue. Glue starts at E, so these are junk. 89, 90. And then we have 92, 91. Click. Yes, and that lines up perfectly. And we have the glue names. Okay, so now X91. That is a bunch of zeros, and then we have a list. I assume glue is going to be a bunch of different things. So, that looks like ID or index. And then we have some kind of flag. Some kind of identifier at 95. Yeah, a bunch of things here. So we have single values at around all the way to 98. They're all glue properties. $97 actually. So let's see what those are. See if we can make sense of what those values could possibly be. So we have glue ID. Yeah, that's just the counter. Glue ID. That's just it's called a flag. IDB is an index that goes to a max of A7. What was that again? A7. It's 167. I've seen that before. Possibly art mesh ID. That would make sense. Or the previous array, the 169, which is actually the number of art meshes. So num unc 11 is actually the number of art meshes again. Possibly. Let's call this art meshes 2. I feel like what's going on here is that they have been extending this file format, and the way they've been doing it is by adding new arrays at the end that add properties to existing arrays, which is why some of these get duplicated. So we have an art mesh ID, and then we have another art mesh ID. You probably glue one art mesh to another, right? That would make sense. And then there's another one. No, sorry. And then D is, okay, that's interesting. That goes all the way to 82OB 2946. Possibly index buffer. They're all a multiple of 2. It sounds like an index, although they usually index by numbers, not by... so it might not be that. 2946. But they don't start with 0 though. So wait, no, it does actually. The first one is 0. 2994. It's Ankh 13. This is Ankh 13. Okay. And then I'm guessing the next one is count then. Yes. And so then the next one is Ankh 13. And those are floats. And it looks like after that we have some indices. Zero, zero, one, one, two, two, three, three, four, four, 5, 6. Interesting. So these will increase. Yeah, these are some kind of indices. Assuming it's also Ankh 13. And we need to uncomment more of these. Yep, that count is correct. So then we have a few floats. So that's a new count. This is Ankh 14, I guess. Which is glue again, I think. Yeah, and then glue too. So this is another thing they extended afterwards. Glue, Ankh float. And then what do we have after that? Then we have a bunch of flags, and it's longer, so that's not glue anymore. That's Ankh 15 probably. That's a lot though. Let's see. So this is all going to end up into most likely some Python I will write to de-swizzle these things into structures that make sense. I probably won't use construct that much actually, because, or I might use it to define the top level like arrays, and then have some Python sort of construct them into objects that make sense. Because this is all very regular in some ways, the way that the header has all the lengths and then they all point to each other. So we'll have some fun decoding this. I think after all these arrays are decoded here in imhex, I will probably move to Python, because it's going to start making more sense to look at it that way. Okay, that is not the right length. The length we actually have here is starting here. So this needs to go away. Six, 5, 6. $164. I've seen that before somewhere. Yes. Ah, num something deformer 2 again. And that time they didn't repeat the flag. Unless... Nah, yeah, that's just something deformer too. Oh, no 15 and 16 have identical numbers. Oh, wait, no, this is wrong. That's not, sorry, I'm confused. This is not a 15. This is, num something deformer 2. Yep, that's right. And then X102, now we have the same thing, and these are zeros. And then some indices into something. Is that right? It might not be right. The flag. No, I think these are different. We have the flag and we have the other one, and then this is a different thing. Different count. No, this does, it does work, yes, sorry. But this one's wrong. The 0 one is wrong. The flag is right. This one is not right. That is F80. Three, 3, 6 somethings. Or a bit less. Is that just double? Oh yeah, it's just double, okay. So this is a U32X2. And then we have a bunch of counts again. So we have index and we have counts. And it goes all the way to 107. I think. We're getting close. We have to get to 150. We're 2/3 of the way done. Sorry, these are... I messed something up there. C is different. C is different. That's a different account. E40, 140. AT. What is size AT? Actually, less than that. $77. I remember that. The former 3. Okay, so that's 3. But that's different though. This one is bigger again. D100 minus E40. $176. I remember that. What is that? No? Hold on. Let's actually get the exact number. That's another index. And that one's fine. This one though, $169. Okay. Num art meshes. So we have this one is an index. And then something 3x(a) is another index. And then we have our meshes X index. So this, what's this 748? 1864. Is that a number we have in the header? Yes, num unc 1. So this points to unc 1. This points wait, does it? No. 748. No, it doesn't. And actually increment, so it's not bad. This floaty index buffer stuff. 94A. 2378. Yeah, we'll see. I think that increments. That might be an index buffer. What about something 2? $736. 1846. That one could be a pointer into a thing. Because we got a count. The last count is 0. No, that's not a count. This is possibly just 2. No, this is a type or something. No, sorry, that's a counting of the first index. Okay, what is this index going into? This index is possibly vertex index. VBO stuff again? 1. CO2. Yeah, I need to figure out these ranges later, but that looks like it could be just VBO vertices. So this is the only interesting one that has a 736, 1846 max. And it counts by 1 and then like 9. I saw that somewhere. I remember that. It's the same as this one. It's the same as the maybe vertex offset, which I'm pretty sure is not vertex offset anymore. I think. Because that goes up to 5D9. Zero 1 829. Yeah, it's related, and these counts are 0 1 9 1 1. And here we have like 1 9 and then more. Yeah, I don't have those counts. Yeah, I don't know what that is. Anyway, then we have that index there. And then 108 is... let's do FD80 minus D100. That's a big one. And these are floats? Yes. 2848. Ah, there we go. That's UNC 15. I think these are all the same counts, and these are floats, probably still floats. I feel like these are all properties of the same AD. Yeah, up to 13, I think these are all properties of the same thing. Yep, that looks right. All the offsets look right. So what are these? A is floats. B is floats. 2. C is also floats. So these could be coordinates or something. D is unknown. And E is zeros. Yeah, so these are all zeros. Actually, I'm just gonna assume they're all floats because this sounds like it's likely like a scale, like offset type of deal, right? If you have a lot of floats that are, you know, 1, 1, 1, 1, 1, and then 0, 0, 0, 0. That sounds like it's most likely scale X, right? I'm just gonna wing it, but scale X, scale Y, scale Z, and then offset X, offset Y, offset Z. That makes sense. So then 114. We have some flags. More than a flag, or no, it's not that big. How many flags? Well, it's probably 16 just going in order, right? No, actually, 15 and 16 are the same. So these are probably like that. Yes, and then we have Ankh 17. Size 13 is interestingly small, but that makes sense. That does not add up. We have 112, or a bit less. Could it be multiples of 8 words each? That would be a little strange. Am I doing this right? D00, DEC0. Oh, sorry, no, it's 2C0. 176. It could be art meshes again. Sorry, it's the other way around. This is 114. No, what am I doing? 169. What did I just do? I just did something dumb. Where did I get 2C0 from? I think I just had a brain fart. Oh, hold on, 115. I forgot 115 here. Ah, yes, it is. This is right. It's a number of art meshes. So it's a flag, E3, E0. Okay. And now 115. How big is this? This is another flag. Same deal. Another art mesh flag. $116 looks similar also. Let's see if I got that right. Yeah, I got that right. Okay, so we have some flags for art meshes. And the second one is not a flag. The second one is probably an index into the next array, which is gonna have a few. Yeah, I think so. Because we had a really small one after that. You know what this reminds me of? This reminds me of a database. It's almost like they got a database and they made it into like a columnar database and then like normalized it. It's like everything is normalized somehow. They have like so many arrays of things and not inlining anything. Unc 17. Yeah, this just keeps going. Okay, that goes all the way to 120. So actually, this one. And what are these? Looks like more indices and then counts. Possibly VBO counts and then flag? Possibly? So at 120 we have again a bigger number. Where's our header? Unc 18 sounds about right for the next one. Yep, that's right. And what is this? This is a count-ish thing, or possibly a type. Then we have an index. Actually, though, this could be an index into Unc 17. Yeah, this is an index into Unc 17. So normalized. and then account. And then we have another set of things that possibly could be indices into what's 1D. Something like 29. What do we have 29 of? 21. But it should be 30 though. It could be an index into Ang21 plus 1 though, one of those things. And then we have flags. And then we have another index into something that goes to 99. 153. Unclear. That's wrong. That's not A, and then B overlaps. So B is nothing else. Only A here. A is a flag. And then we have $80 of something, a little less actually. Uh, 71. Okay, that's Ang 19. Click. And we have more of those. Until 128 actually, so one more. So the first one is an index that goes up to 99. The second one is an index that also goes up to 99-ish. And the third one is count or type. So the third row has a 3. Do we see an increment there? Yes, that's a count. which means the 1461 here. And that's a count. The last one is 92, and then we add... Sorry, that's not right. Index... Oh. So that's this one. So the count is 93. 147. Do we have a 147? Well, that's an interesting thing in here to have a value in. But that's not what I'm looking for. No, we don't. Unclear what this is. All right, what's X128? A very small thing. That says 15. Okay, that's UNC 20. And then we have, oh, these are all the same. Okay, so we have a bunch of these. Until here. 130 is still okay. Okay, there. 120. So A is an index max 8A. B is max 176. And C is a count. Starting to think this might be one of those like parameter related things because we have 176 here. And 162 params. Yeah, so it's like consecutive with UNC 19. Okay, let's see where the next ones take us. So 131. We have a flag and they're pretty short. And then we have some 2s. So that's the 29. Okay, that's 21. And then we have 22s. And for Rank 22, we have looks like 3. And we don't know what they are. Okay, 122A, B, C. So this is 2A, whatever that is. It's pretty clear that nothing is obfuscated here, by the way. If something were obfuscated, it would stand out. Everything here is very clean. I don't know what the parts are, but nothing looks strange. So I'm pretty sure nothing is obfuscated here. All right, so what's 23 here? 23 is 6. Yeah, that sounds right. And we're getting really close to the end. And those are floats. Then we have another index business, and that goes... Oh, that's pretty big, actually. $2754. See what we have here. A1720 9F840 1888. Yeah, it's Gibson. Ah, that sounds like Naman Kwan again. So this is an Ankwan extension. Then after that, we have another identical-ish array. Looks the same. Clickety click. Yeah, that's right. And then we have B80 minus 540. $400. It's a little less. It's B44. 385. Aha, that's UNC2 extension. Yeah, I see where we're going here. Okay, 139. And 140 looks like the same business. And 141 looks like a different size. So 141, we have B00 minus 1C0, divide by 4. 592. Aha, that's UNC3 extension. And I'm just gonna guess that it's also a pair of indices like that. And we're almost there. That one is not right. Oh, sorry. Update that. Okay, those are like index buffer indices, possibly. 74B to BOB. 1867 to 2827. And these others are essentially 0 to, this one is 0 to 22754, and this one is probably the same. Is it? B1D. B1D. Yeah. Just write down the ranges of these so I can try to correlate them with something later, but they are possibly index buffer, possibly something else. No, I'm not going to do a converter to CMO3. Read the FAQ in the stream, or watch the beginning of the stream. I'm not working with CMO3. No plans to do that. Okay, and then we have some short ones again. We have 7s. I think that's the number we got here. Yeah, that's UNC25. And then we have some empty arrays at 149. So we're just gonna guess that there is a num UNC26 in here that we don't know about, because there's empty space at the end. Oh no, these are empty, sorry. 3, These are all empty, actually. 3 through 5 are empty. Then we have that one. Was there a 0 there? Yeah, there is. 24. Okay, so that's Ankh 24. There we go. And that's the entire file. And these offsets go from 0 to... let's write down what these are. Okay, that's an offset and that's a count. Just guessing by kind of how that works. So what is this 0 to 13 stuff? It could be an Ankh 17 reference. Could be an Ankh 20 reference. And then we end at 184 with a count of 2. That's Nama Ankh 18. Because that ends at 186, and the last count is 2. These could be an Ankh 15 reference. But we don't know. Okay, there we go. So now we have at least all the top level of the file mapped out. I think without messing up too much. So I think the next step would be to put this into Python and try to make sense of the file in a different way. But since it's getting a little bit late, it's been 6 hours. I mean, I can still do a bit more, I think, today, possibly, maybe, not sure. Let's see. Just checking my notifications. Think. I think we'll maybe call it a day, or maybe just start doing a little bit of the Python, just the proof of concept that I can represent this in Python. Where's Cyan? I'm not sure where she is. She was going outside. I'm not sure if she's still here or she went somewhere. Yeah, I think she's like shopping or something. I do feel like I could use a snack though. But yeah, at this point, I'm gonna be putting this into Python and looking at some of the offsets and ranges and seeing which makes sense as like index buffer ranges and things like that. And then it might make sense to start looking at some cubism documentation just to sort of make sense of what we expect to see. You know, just stuff that is publicly available without any licensing or anything like that. I need to figure out how to plan this out into Python. Okay, I'm gonna take a quick break and maybe grab a snack at the convenience store or something like that. And then we can try at least putting some of this into Python. All right, be right back. Alright, I'm back. I'm gonna eat something. Actually, I need to get some water too. But I have some drinks. I'm gonna eat something. I have a plan. I've been cooking a little bit. So I think the way we're gonna structure this is we're gonna use construct to declare the top level structure, the like array counts and stuff like that, and the arrays. And then we're gonna have some like some metadata in the arrays that tells the arrays what object how do I put this? What object path they pull the data from. And then we're gonna have either regular Python classes or some kind of data class type thing to represent the actual like rearranged objects in Python. So let me eat a little bit and then we get started on that. I think we can get started. So let's see. I want to make a probably an actual Python repo here. Sorry, I meant a Git repo. And let's see how we get started here. So I need to remind myself how construct works. And actually, I'm going to look at some of my old code because there's a bunch of construct stuff here that I might want to steal that I worked on a long time ago. Construct details, this one. I might want to steal some of this because there is most of this I don't care about, but I have some like pretty printing magic here that I might want to kind of abuse. Like this construct class-based stuff. But I don't really need this because I'm only going to use construct for like the arrays and the metas, so it's not going to help me that much. But I might steal some of this for the actual. Maybe no, actually, I don't need most of this. I'm just thinking to myself if I can use some of this, but I might be able to use some of the info here and just kind of steal patterns. Okay, I need construct. Python 3 pip dot venv. Takes a while. That's slow. Okay. So yeah, I think I'm just gonna do the this old school struct stuff because I only really need to do some very simple things. MOC3 file equals struct. Actually, most of the file is gonna be read as arrays of arrays, and I don't even have the. Do I want to do it like this? I guess this is useful for pointery stuff. Anyway, let's go here. Let's copy and paste this entire thing. And go up here and start here. So, MOC3, let's do header. So the header is just the magic. And construct docs Python. Take some of this. I think I can just do that. Have you tried and justified on main common things like your events and routing people updates? I don't really do it that much. I actually only really started using virtual environments consistently now that I use macOS, because in Linux I used to just install like for dev stuff into my user local Python directly, or use distro packages, which there's way more Python packages in Fedora than in like Brew. So yeah, it's not that big a deal. Alright, give me some fixed length strings. Yeah, this is padded string stuff. Ancient data formats. Well, that's what we have. Greedy string. Is there a magic? I think that's a magic thing we can use, but I don't do like a regular fixed string, not padded. There's the actual string stuff. For API strings, padded string, Pascal string, C string, D string, 9. It's not a magic constant. Where's the constant? Constant. I could just use a int32 for the magic anyway. Oh, you can just use the B. Okay, yeah, that makes sense. Is that how you did? No, I need quotes on this. So the syntax here is a little funny, but this is how the construct API works in Python. So I need like padding here. Yeah. Alignment and padding. So what we have at the top is 40 alignment. And then we have the offset array, and that's seems to have a fixed size of 780 for some reason, but then only some offsets are defined. So so that's not aligned as much as like a fixed size struct. I guess I could just add padding at the end, but I think there's a fixed size thing you can do. Yeah, fixed sized. Yeah, so we can just use that. Which means I can actually just use fixed size here too. So we have 151 offsets. And these are all actually, since these are all consecutive, I think we can just hard-code an array here. So you can just take, oh, it's 480. Okay, yeah, that makes sense. And then the weird thing about this is when because eventually what I want to do is be able to load a MOC3 file and write it out without losing anything. That means I need to recompute offsets eventually, and you can do the build stuff, and then you would have to like, I think it probably makes sense to, does it make sense to build these as a string? It might. But you have to use like tell on the arrays, so it's a little bit annoying. I feel like then I probably don't want to necessarily store these separately, but rather as a... Do I want to do that? I'm not sure. There's the tail stuff, but I need to like figure out the position of the other things to go back. Yeah, I mean, you can use pointer, but which is what I want for parsing. I think I need to use custom code to declare the arrays. So the arrays are not going to be here. Let's just make these like that. I guess that makes sense. MOC3 header. And then the array is just gonna have to be a different story. And we parse and build them separately. So the first offset is actually going to be special case because that is not an array. It's kind of an array, but it's actually a it's not a flat array. It's an array of all the lengths. And this mfloat is really interesting because there's some stuff there that is not clear what it is. So I might want to use pointer for these. There's 5 of those, and there's not really any count of 5 in header, so... I think I can just probably make this part inline and everything else different. So for array lengths, I'm gonna call these nux0 and nux01. Actually, no, instead of unc, because unc is a little bit, it's hard to certainly replace for because we're gonna have more than one unc thing. Let's call this unc A02. Because I want to be able to search and replace things later. Oh, how do I replace here? Right, search and replace it. F. Command option F. Does Sublime have block mode? Because I use that all the time in that sounds like it might not. Might not. Okay. I think in the search and replace, yes. Replace in selection. Hmm? Hmm. There we go, something like that. And so then array length is itself padded to. Is it padded? No, it's not. That's just a line, like the regular one. So there should be a line to 40. Actually, no, it's not. There's some extra stuff at the end. So that was at the 880. Yeah, so 78 bytes of padding. Or if you just use the total size would be that makes sense. It's 256 bytes. And global floats in this case, yeah, after that it's just standard alignment. So that one I think we can just keep. And then we need the actual arrays. So we're gonna define those as a, like meta thing here. Oh, how's it going?
Just 2 minutes. I mean,
It's fine. You'll survive.
Oh, hungry.
I just ate.
You just ate.
Because I just got some convenience because I was hungry.
How could you cheat on me?
I didn't cheat on you! It's a convenience store.
How could you cheat on me? I was thinking of making you food. It's okay.
I'm sorry.
I'm glad you eat. How is everything?
I'm doing okay. Just starting with the Python, but just gonna write a little bit of this and then I'll be done. What?
A little bit, you'll be done. Like tomorrow? Madasta?
Give me an hour.
Yes, Cyan. Hello. Kiss Cyan for us. Hey, just待って.
Huh?
You have sauce.
I do? Wait!
It's Bolognese.
Huh?
Bolognese.
What's Bolognese?
The meat pasta.
Bolognese? But it's not Bolognese. I didn't eat Bolognese.
Niboniese?
Never mind.
Hold on. Do you need anything?
I think I'm good.
Okay.
Mm.
Bye-bye.
Bye-bye!
Madasta.
Alright, woo!
Did you run out of water?
Yeah, I did.
I don't need anything. I'm good.
So let's see if we can make sense of this. So we need some extra weird things. I think there's a tuple thing in this is named tuple now. Oh yeah, this makes sense. So I think we can just do that. Yeah. Yeah. I didn't realize you could do arrays with square brackets now. That's convenient. So we have a type. And then we need a count field. And then a field, and we need a actually, we need a class, and the class probably should just know which count field it uses, I think. No, but it needs to be a yeah, this needs how do I want to do this? We have parts that gets indexed by the index, and yeah, I think we can just do it like this. Let's see if we can make sense of it like this. So let's do a couple as a test. Identifier. Actually, this order makes more sense. I'm trying to figure out if I want to be smart about this and like do the S's at the ends automatically or something. And we need some special cases for like VBOs, which are just flat arrays. I could make this kind of a little more nested like that. Maybe it makes more sense to do it like this. So we have a class called part. And then we have a list of fields. Does it make sense to use the / syntax? It might, because I think we can extract that with I think I can abuse this feature of construct. Okay, let's see if this makes sense. Let's delete all this. So let's have data, and we want to parse the header stuff first. Can I do a split view? That's always nice when I can do that. Layout, columns too. Yes. Can I get the same file? Split view. Oh, that's what I want. Okay. Layout. Single. Yes. Let's do this. And it arrays. And I can probably put this into the MOC3 file stuff. No, it can just be out here. So we do for not in arrays, init objects. Init objects. So we do a set item like that. So then we need a class part. And we would set defaults for the actually I can just set defaults for these, so I don't even need that. So inherit from like a struct, which you can declare. And I guess that means arrays can actually be a dictionary, or we could no, because we're gonna have to repeat things for extensions. So that we can just look through arrays and put this at the bottom. But this is a little confusing if you do it like this. How do I do this? Because we need to handle the extensions where they add things out of order. So it might make sense to just do it like this. Yeah, I think we can just have like the extensions separate like that. Or maybe just call it base. And then like ext1, ext2. But then I need a way to address these in HStruct, and I don't want to enumerate. Then I want to do meta class stuff. So actually, no. Let's do it like this: fields. Just a 0. And then MOC3 could just have a actually set attr. Do I want to have the part stuff here? No, because then it's redundant again. So then we can put this in MOC3. Nah, it can just be inferred. But we might have repeat classes, maybe, of different types. Not sure. Yeah, let's do it like this. Because we need the lengths to initialize some of this anyway, so... we need like part and the count field parts. It should be the same as the actual field. And then we want I think that's it. Okay, so how do we actually parse this? First I need to initialize here. For let's see, for group in subfields. For field and group. Let's just do a print field for now. Let's call this init address. So first we want to parse the header. The header would be MOC3 header. Let's do a print there. Let's see how far we're at so far. Where are we? Come on. Identifier, we don't, that was a, padded string. What is that called? Padded string, length encoding. Okay, so we have something. Offsets version. Yeah, okay, we got that. The offsets look good. And, oh, that's not, the length of the offsets is not right. Because that is... $780. Not hex 480, actually. It's decimal 480, 1E0, so. Okay, that's our offsets there, and then we need to figure out how to print this. Is it repr? What did I use for this? I did use some kind of. I always forget if I use repr or string for my debugs. I usually use this dump thing to dump as text, and I might want to just keep that. But I also have the str. Okay, so where are we? We print the header, do the set attribute. Text rec is a useful thing. I think we have that. Okay, so let's do so let's do a oh, I can't change the split. Okay. Make this a little bigger then. I want to do the syntax here. It should be str, not repr. Metaprogramming. What's going on with in the chat? Can you use the runtime SDK and copy the importer from it? The SDK is a binary for the file, so I can't use that. And even if it weren't a binary, the license doesn't allow using the SDK in open. It's not the license. The SDK requires getting a license from them. Like you have to negotiate a license from them if you want to release anything using the SDK, and they will refuse to do that if you are developing open source software. so we got MOC3 parts. So now for the arrays. And in this case, we don't need that. We need these parts, actually, or... No, part is fine, but I need to know the object. Yeah, I think that works. So for field group and arrays, we do for I need to get the this is already done. I need to figure out which class this is. Let's do it like this, actually. This makes more sense. Use a dictionary. For field group in arrays, we do for we grab the class and we say first we actually need to create the yeah, sorry, I need this because I need to fill out these fields with default objects. So for field class, I'm saying set header field and so it's self header dot I need a lengths and global floats in here. Is that gonna work now? Probably. Yeah, okay, that does work. And I want to print these as hex and let's do this as hex by default, actually. Oh, why is it? I don't need the padding. Oh, that's annoying. I think I fixed that here. This hex is split integer. That's not in there? Should be. There's a format string thing. I thought I didn't have the leading zeros thing. I think it's because I printed like this. Yeah, that's nicer. And actually the length shouldn't even be hex. These are probably just better as integers. But most of the other things I would want as... as something like that. Yeah, so now we have the offsets as hex. Or I don't. Ah! That did not work. Possibly because arrays don't work. No, that does not work. Whatever. Don't care. I guess that doesn't work. And this doesn't work either, I guess. Yeah, it doesn't work, okay. Oh, actually, I know why. Or not? And then I need like a list container thing. Not here. Here. It's like it's missing hex displayed list. I think you can just list container it. Yeah, there we go. Okay, that works. And why is this hex displayed? Why is this uppercase? I want it lowercase. I like my hex to be lowercase. Why is this upper? That's so silly. Who decided that hex should be upper? I don't like it. And let's do it like this. Okay, cool. That's how I like it. So now the parts, we have no parts. I need a get attribute header, and that's called lengths field. Okay, so now we have something going on here. The same kind of story here with the fields. So then we'd go for group in self fields. For field in group. And then I have this renamed thing. So I can figure out how that works. If it is a renamed field, shouldn't really happen, but just in case. And yeah, actually, we don't have an and, we can't do that. Let's do an assert. And then we do name subcon. Value get added name. There we go. So now there's no unquan 0. So now we need to declare, do the initialization here for field and group. Group in fields. Assert rename, name. And then I need a default value for that field. How do I do that? Everything needs a default in these parts. Well, since everything needs a default, I can probably just use an extra layer of stuff here. Is that better? Yeah, it's better than writing default everywhere. I guess if I'm gonna do this, I might as well not use the renamed thing. But the thing is, I can probably update these so they have better defaults. And then avoid this whole thing here. Yeah, let's try, how do I do this? If I find default, it gets value. Or I can just have the default for everything be 0. Or I can actually maybe just construct and parse. How do I do that? If I do, I just glitched. It does build and then parse. Okay. Can I just do that always? What happens if I just do that? Yeah, it doesn't like that. It needs a default. To a list when you give it no default. So default doesn't work with lists. Is this one failing or is the other one failing? That one's failing, okay. Okay, I think that trick works. I just use all zeros as a default value, which makes sense. And if you need a different default value, it can be avoided. Yeah, so let's just do it by having a if you use default, it'll override the default. Okay, there we go. So now int object, where is this coming from? Where is text wrap indent? Hold on. Can't type. Text. Oh, it's text prefix. Okay. Okay, there we go. That's looking more like it. Here we go. Parts 0 equals part. And then we need to print these fields. We're printing this. Its name equals value. There we go. And probably add a new line after every object type. Now add the name. Okay, so now we actually need to parse these. The Excel arrays. So here in parse, you can say class load array, and oh no. How did I get numlock? Caps lock, what? Oh no, what? How? Okay, like that. We start at index 2. Actually, no, it just need to be offset. And we also need the alignment, so it's more like offset. But for parse, we are looking into the this.offset. So yes, index equals 2. Yeah, something like that. Okay, so load group. And just to make sure that we are correctly limiting the length and nothing overlaps, we take the offset as the offset. And if it is the last one in the file, we say the length equals length data minus offset, else length, say length, size equals this one minus off. Actually, it'd be more like end equals length data, end equals offsets, n equals 1. Field in subgroups. I need to pass the group ID here. Sorry, like this. Load group for field and subfield group. Load field. And we need to get the count. Mm-hmm. And for the length, we can just use the length of the array. And these should be actually class methods. Let's call this objects. And now we have to set the field name. So field data, okay, so subcons, actually we want field.subcon. And the trick here that what I want to do is that if I have nested things, how do I manage that? That's a little tricky. Like if you have X, Y, Z, how would I do that? I could nest it if I nest an A struct. That gets a little complicated. I guess it'd be like a name tuple, kind of. I might be able to abuse this adapter in construct. Yeah, you get a tuple name, a tuple fields, a factory. Again, I think I'm gonna cheat on this a little bit. So if I do I can just create a dummy thing and then handle it specially when loading. Field.subcon, it's not gonna be recursive, but I probably don't need it recursive. So field subcon, so that is only for things that have the same yeah, the same type. So I need like an array struct. But for this we'll do a tuple name, tuple fields. So assert that the subcon of that is an array. And it has a count, so attributes. So instead of that, it would be objects I get attribute name I equals something like that. Okay, let's see if this works. Part unc10 name identifier. Hey, we got the names. So that works. Now let's throw more things in here. There we go. Now we're getting some nice flattened fields in here. So deformers. I'm just gonna call this header because I don't know what this is. I'm just gonna use pointer. Actually, go ahead. I unc5 for like pointers into for indexes. And now we have some deformers. So then the other one we have is UncAO2. And now I have this UncAO2 thing. Unc AO3, another Unc 5 index, and then offset, count, and Unc float. I love it when like little frameworks like this start to, like metaprogramming frameworks like this make sense and start working. Hey, there we go. Okay, art mesh. Pass art mesh. Let's try the array tuple thing. See if this works. Aha, that doesn't quite work. Array tuple. Oh, because it needs to be that. Okay, good. So header does not support item assignment. Because name tuple is not modifiable. Yeah, this is a little tricky. Okay. Let's cheat a little bit here. This is evil, but okay, that needs more. Yeah, that works. Okay. Okay, that works. It's ugly, but it works. So my array of arrays nonsense seems to be working. Let's call that header, because whatever. And then we have the name. There we go. Now we have some art meshes. More stuff here. Counts. Good. Now we are getting somewhere. Now the parameters. Verify that I deform and matches assess number of deformers. Yeah, I'm gonna do like a verification thing later for the I fields. I think there's gonna be like a separate verify pass after that. Because I don't have access to the other structs while instantiating these. So I will do some kind of verification pass. How does one regression do in your file format? Well, watch the stream. But initially just by looking at it, and then later there's two ways. You either look at different files, but I don't have the way to create these files, so I can't do different exports. So instead, I do it the other way around, and I will be modifying the files and seeing how they change the output in VTube Studio. But so far, I'm just basically doing educated guesses based on, you know, the data in the file. So we have the parts, name, identifier, and then parent max, so max. Actually, I can use a rate tuple here. Makes sense. Oh my! Why do you? What's this?
A cocktail.
A cocktail? What, do you want to get me drunk?
Yeah.
No, seriously, what is it?
Cocktail.
Is it Sika?
Cocktail.
It's really good.
Yeah.
Thank
It's
you.
all yours. Be drunk.
I don't think it has alcohol in it. But I sense some like Sika and mint.
No, it's dragon fruit.
Dragon fruit. Oh, oishi.
Just kidding.
Okay.
How far are you?
Oh, pretty far actually. I'm just.
Don't drop it. I
Oh
got it
yes,
from
yeah,
Taobao.
yes. I'm just translating this into this format and I'll be done. And that's the end of today. So it's literally just converting some text now.
If you don't finish it, I'll cry tomorrow.
I will finish. I will finish.
But don't drop it. I'll cry tomorrow.
I won't drop it. Okay. So I should add a length verification thing here. Because we have some weirdly duplicated lengths, so because I guess technically these might be different structures in that the way Live2D defined them, they are separate structs, but the length is always the same. I'm just gonna merge them, so. Wait, this is part 2. So this is actually the second group of parts, sorry. Mime parents or mime parts? Where am I? I just lost myself. What did I mess up here? A comma. Okay, something wrong here. That doesn't sound right. What happened here? How did I end up with the number of params being the same as the number of art meshes? It's supposed to be 169 and 162. Oh, no, I do have 162, sorry. Wait, what about the array length? No, that does... Huh? I think I'm not in... Hmm? Something's not right about the data size. I guess it does round the same. But then what happened with the headers? That's not right. Param? I think it's not right here. It's not a header, it's... Wait, is it? It should be. Oh, something's wrong here. FD80. Oh, hold on. I'm not incrementing the offset properly. What happened here? Probably because this index is somewhere I forgot to increment properly. Yeah, I need to return count from load group. Or even just index, actually. So param, header FD80. Something's wrong here. Zero at 13380, yes. Type a 4 maybe. That's fine. And then E80. Wait. BC0 is flag. Where are we off? Type 900? No. 0, 13380. Okay, limit is wrong. Limit starts at... No, 13380 is 0, yes. Flag 13BC0, yes. Float 13E80. Yeah, that's right. Sorry, E80 to F80. E80 to F77, that's fine. Oh, that's part. Sorry, it's part. This is this is part. So this now is a second group in parts. There you go. So now in part, we have that unknown float and it does parse properly. Excellent. Okay. I can probably change the way this is printed too, so that it actually separates the groups. There we go, group 1. Okay, and then we have unknown float and VBO index for Unc 1. Should just create a template here, so I can just keep referring to it. There we go, Unc 1. How do I know that's a float? Because it does do 1-0 for some stuff. And some of them I probably will like simplify the representation so it's not as long. Probably, instead of having val, I have a backslash n here. I probably want to put this in the string here so that then it can actually no. That makes sense, and then it just removed the initial new line on the other one. So for example, for this one, I can just say, but I still have a new line. Oh yeah, I do. So actually, I don't want to strip this. I want to outstrip this, and then put the new line in the other one. Or actually, I think they already have them. Yeah, they do already. Cool. Cool, cool, cool. Now on 2. And this actually just has 7 floats. So I can just say vowels here and call it a array tuple. And print this one as just a list. Yeah, there we go. Because we don't know what those do. And then Ang 3 has 2 floats and a VBO index. Go. And then we have the VBO. The VBO is probably going to be special. Because that is really just a big array. So we need a special case for this. Is subclass. It's not a subclass. Okay. I need if how do I check if something is a class in Python? There's inspect is class. Okay. Okay, there we go. That's the VBO stuff. And I probably just don't want to print that because that's kind of ridiculous. There we go. So we don't want to print these things. They don't make sense. So that works. And then we have Unc 4, 5. We have more things going. Okay. That looks weird. That's not right. Oh, I didn't increment it for the VBO? No. What? Yeah, I think I did an increment. Okay, that's fine now. Rank 4. That is pointing at 127. I thought we had something about 127 in there. Yeah, Ankh 6. That looks like it points at Ankh 6. Ankh 5. I think it's an index buffer. Let's do 5 and 6 at the same time. Actually, it's not even IBO. This is Ankh 4. And then we have 510. I think we saw that somewhere. Did we? No, that was one we did not know. The 510 one. It could be Ankh 3. It could be something else. Alright, and then we have Ankh 7, which is mental floats. Let's make a subclass for simple value classes here. I'm considering those distinct from the VBO because those are much shorter and they do want to print them. I need, not type, is it class? Yeah, that should be fine. Actually, that is a lot. So I don't want to necessarily just print floats like that. And they look like, oh, this looks like texture coordinates actually, kind of. I could believe this is texture coordinates. Because they're all in pairs. Hmm? Oh, I need to rename it in the header one. And this previous one kind of sounds like parameter related. This sounds like parameter key points or something like that. Because, yeah, this looks like parameter key points or something similar because we have groups of 3 and we have groups of 2. So then we don't need a special class for these, just print them as float32L. And we'll figure out how to map them later. So then that makes sense possibly as mapped here. UNC6 sounds like a key point map. And then why do we have a different number though? Yeah, see, then we have this minus 30 to plus 30 thing. And those are the 13s. So this matches up, so why is it not lining up exactly? Like 167 here. No. 42. Start 42. Yeah, that is a list. So why are we ending in 507? And there's more after that. So multiple things index into this one. Okay, so now we know what UNC6 is. This has to do with the key point, I key point. So then we're looking at something that starts at 510 somewhere that has a similar number like that. So then this one here is a mapping to, looks like key point ranges. Key point arrays. See, now this is starting to make sense. So let's turn this back into float 32L so it doesn't print. And then you know what? I kind of want to start assigning the globals in here so we can do more custom prints. So if I just give it self in here, we can get at other stuff. And then we can start doing custom things, like the key point array here. Look at that! Now we have the key point arrays, and they make sense. Key point 552 is same as 42. Key point array copied? What do you mean by that? Like, if it's just duplicated, maybe, but it actually, the number doesn't add up to twice either, because it would be 510, so it'd be 1020, and it doesn't add up. So I think there is something else indexing into this. So Ankh4 looks like it's just indexing into key point arrays. I have no idea why there's this indirection, but I guess that's fine. So then we have 151 thing here, and that is interesting. So Ankh 5 is mapping to key point arrays. This is now starting to make a lot of sense. So we have 124 list of key point arrays, and then the parameters probably have something related to that too. $127 parameter, Ankh 4. So that's actually going to key point arrays. Okay. There's -1s, but yeah, it looks like it's 127. So that means we are looking at key point arrays again. I can add a little trick here for formatting things like that. So in param, I key point array, I can just say def as I key point array. And means I need to indent that. There we go. Now we have a key point array. Does it make sense? A lot of these parameters are not particularly well indexed. But look, the limits make sense almost. Actually, why is oh, that's broken. Ah, that's broken. The limits thing here, that doesn't make any sense. I think I have all the limits set to the same thing. Arrayed tuple. Something is a little broken here. I need to like increment this. Line objects of con. Yeah. Load field. Yeah, we passed the data with the end like that. That's not gonna work. I think I'm just gonna move this to the other things. Instead of data, we just pass the whole data here. Okay, that looks a little better now. Yep, that looks a lot better now. Okay, good. It's getting a little ugly, but toop, 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 toop. There we go. So 1 max min 0 default 0, and for example for the 30s we have max 30 min minus 30 default 0. Yep, that lines up with the key points. Hello, if you did any disassembly or decompilation of the Live2D software, then I have to ask you to not participate in the conversation because I would like to keep this clean, please. Okay, and where are we? X chords. So then we have an IBL. And then Unc 9 is a U32 value. Don't know what it is yet. So yeah, no idea what this one is, but we have 30 to 108. Unc 10 has 5 parameters in some kind of tuple thing. And that is all we have. Were those just empties? I think they were. Yeah, it's just one. Okay. Ank 11 is extension to art meshes. Yeah, so this looks like some kind of index thing, and I think they're all yeah, it's unique. So it's like Unk order. It might be a Z index. That would kind of make sense. Let's get Unk order. And then we have a lot of -1, so... But instead of maybe parents, and this is called optional index, because if it's next to the order, I suspect this might have something to do with being able to change the order of art meshes dynamically, which this model does not do. So this is probably an index into a something that is missing. Okay, then we have the glue array. And we have the same 0 then, and then the names. Looks like we have a mosquito. I lost it. I don't like mosquitoes. So for glue, we have cat and then an unknown float. Air and bath. This is 16, so not VBO, maybe. Okay, that kind of works. Yeah, so those are indexes into Ang 13. So no idea how glue works, but it looks like this has something to do with weights. Looks like every pair has an index and a weight. So possibly the art meshes, this one does art mesh, this one 0, for example, it has 303 entries. What about 36 and 39? Yes, it has 33 texture coordinates. So they have the same number of texture coordinates. So it looks like what we have is a glue entry. Thank you so much for the gift memberships. Thank you so much. So another 50. This is like, we have like 100 subs right now. Thank you so much. This is crazy. we're getting somewhere. So I wonder how this weight thing works, because it's like, it looks like it's basically taking pairs of art meshes and like I guess it kind of makes them get together. I think if I Google, how glue works in Live2D, it'll probably explain it. But yeah, it's kind of interesting. So these are always in pairs, somehow. So I guess the counts are always going to be, yeah, they're always going to be multiples of 2. Yeah, so like it sticks to art meshes to get the vertices, but like there's like a weight to each vertex somehow, right? So I guess this is kind of like they stick together by an amount of each other. So I guess if the weight, do they always stick like permanently, or are they just or are they like partially sticking? I don't know. Maybe there's a separate because there's a separate glue. Oh yeah, this is okay. I'm guessing this is a strength 1.0. That's probably a strength. So there are weights to which art mesh takes precedence for each vertex, and then you would have probably a effect strength or something like that. Is what I'm guessing. Now the weight is which one takes precedence. Like if an art mesh is deformed, it seems it has a weight for the one art mesh and the second art mesh. So the weight seems to declare which of the two is like taking precedence, but then it seems to be like a separate strength for the glue effect. The interesting thing is the weights are very different, so I'm guessing that is used when the coordinates are not the same for both, where the vertices are not the same for both art meshes. I'm guessing the weights are part of adjusting, like mapping one coordinate system to another, I guess. So it probably ends up mapping like to corners or something like that. That's probably a simple calculation that is done to make this make sense. So the ones that are 0.5 are fully aligned. I guess we'll see it. If we look at glue here, if we look at, for example, these that don't have the same number, I think. These have 82, so 156 and 157. Yeah, these are different. So, so ID 156, for example, Oh, that's not an ID. Okay, so then what is that? Oh, here, sorry. 156 has 75 text chords, and 157 has 76 text chords. And the glue is doing 82 glue pairs, starting at 606. So this must be doing some kind of wonky like mapping between vertices, I guess. Though I would kind of expect 4 of each, so it's interesting that it's not doing 4 and 4. Yeah, it'd be interesting if they add up to. They should add up to something, I would guess. So, but the thing is, normally they're supposed to add up. Like for the same pair, they do. Each pair does add up to 1. You can see that. So essentially, it is putting pairs of vertices together in the textures. But I would expect like 1 pair to map to 4. I don't know. It's a little strange how it's done. Yeah, I don't really know how it works. Well, we'll figure it out. Okay. We're almost done. Just a few arrays left here. Okay, maybe I spoke too soon, a little more than a few, but there's something 2 and then something 3. So there's extensions to A2 and A3. Flag. And then a 0 pair thing. And then AO3, and then Art Meshes has another index. Yeah, so there's another thing there that we don't know what that is. Why do I think that's an index? Oh, no, something's wrong here. There's definitely an index there, so... Now something's wrong with the art mesh index. Ah, because that's a 2. That's why. Ah, there we go. Now we have an index. Okay, so then we have to coordinate tuples, looks like. Possibly. And let's call this a value because it's actually just one of these. And yeah, that's just a guess because I don't know what this is. It's probably a scale and the translation is my guess. Something with 2845. Ah, it's... Oh, no, it's a scale. Yeah, we don't know what those indices are. Oh, but this unknown index sounds relevant. Five 41 9. Yeah, I think those are probably indices into that structure, is my guess. And then we are adding stuff to art meshes again. Ah, this is the index, okay. But actually, no. Sorry, that's I transform. Unc17. Different thing. Unc17 is as a start next count on flag. Unc18 says an Unc17 and a start index account and a flag. Not a flag, it has an Unc21 possibly and a flag. I'm guessing these are some kind of transformation mappings. Like mappings to parameter transforms or something like that. Okay. Unc19. And then we have UNC22, A, B, and C. And UNC23. Let's just call this one the 2 floats on the back 2 because we don't know what they are. Ah, okay, this is a start. UNC22 is a start an account. And these are the parameters. So this is like a remap. This is a remapping of some sort. It's got remap value. I'll do the pretty printing for these later, but yeah, it's just starting to look reasonable. So probably 42 is like a parameter ID or something like that. I just want to finish this. I'm almost done. There's like a few things left. So there's some extensions to UNC1, UNC2, and UNC3. And then an unknown Vec3 type deal, which we don't know about. UNC24. And that's it. That's all of them. So UNC24 has, let's call this a value. So you don't know anything about them. And that is it. That is the end of getting the basic data arrays out of the MOC3 file. So then we need to start experimenting to understand what these mean and how they work and how to map some of these counts and numbers that I haven't figured out yet. It's interesting. That was like 176, and then we have the 178 here, 184. There are definitely there's definitely interesting indices that I need to start. I need to start counting, but yeah. Actually, you know what I'm gonna do? I'm gonna print the counts when we print the fields here. There, so now I have a list here, and so we have like 184 that makes it easy to reference. Yeah, see, so that's a reference to UNC18, pretty sure. So that is correct, right? And then that means that these are probably also a reference to UNC18. Because they start after that. So this UNC20 start is an UNC18 reference. And that means that this UNC19 one is also an UNC18 reference. And then 153, for example, there's probably a 156 something. Ah, that's the key point arrays. I think. No, 153 doesn't add up. Anyway, we'll figure it out. But yeah, this is starting to make sense. I think it's time to call it a day. I need to get some sleep. It's been pretty long. But there we go. That's the entire MOC3 file broken up into text format, basically. With a lot of unknowns, but still. So, yeah, we just need to chip at all those unknowns and make sense of things slowly, one by one. Alright, thank you everyone for coming! I think it's time to call it a day. Any questions? Anything you want to say before I head off? Thank you so much for the gift membership sponsoring. Thank you. Alright, I think it's time to go today. Thank you everyone. I'll see you all next time. Bye bye. Bye bye. See you next time.